Good afternoon, ladies and gentlemen. We are still waiting for the speakers to join because actually today we are going to start at 1 o'clock. So we delivered apology because the reminder we forget to set it at 12. So uh, we will start this program at 1 o'clock. Thank you. Dear ladies and gentlemen, for your information, today we are going to start this webinar at 1 o'clock. So we are still waiting for the speakers. The committee would like to deliver our apology because for the reminder, is the setting of the email is still the same with yesterday, so it should be at 1 o'clock. So we are still waiting. Thank you. Oh, hi, Anja. I'm sorry. Yeah, still working on the co-host option because I'm not set as co-host yet. So once I'm a co-host, then you will be the panelist. Sorry. Hi, Anja. You are now panelist.
Yeah. Hi.
Sorry.
That's everything fine. Let me start my video. Yeah, that looks pretty fine.
Sure.
Good morning.
Good morning.
Everybody. So Holger is not yet here, so I can try to contact him.
Yeah, but we are going to start today's webinar at 1 o'clock Indonesian time. So
that is half an hour to go, right?
yeah. So
That's good.
no problem. I think just wait for them. Yeah. But still, there is like a miscommunication due to the setting for the reminder from Zoom. So you get the reminder at 12 Indonesian time. So yeah.
That is also nice.
Sorry, everyone.
Hopefully everybody will be in later. So
Yeah.
I will put you the sound off. So.
Okay. Still looking for the others as the panelists to promote the attendees, some of the committee. Oh yeah, maybe while waiting for the webinar to be started, is it okay if the attendee may have like maybe they still have question for you and maybe they may type your question on the Q&A section, right? Is it okay? Okay. So to all the attendee, if you still have questions for yesterday's topic, especially for Professor Anchelabus, you may type your question and Q&A feature, so she can answer. Thank you. We are still waiting for, actually the schedule is on 1 o'clock Indonesian time, so we still have 26 minutes to go. And now there are about 71 person joining, so hopefully the others will join soon. Thank you. Okay, to all the participants, I would like to remind you that we have multinational participants joining here. So we would like to ask you to use English because if you type it in Indonesian, some will not understand. So thank you. Yes, there is one raise his hand. Pak Adrian, do you have something to say?
Can we have the PowerPoint from yesterday?
Yes, of course. We still collect the material, and actually some of them is already in the website, so we will inform you later. Okay, don't worry. Hello, Holger. You are panelist now.
Okay, I still have to unmute myself, but thank you for letting me in. Good morning or good afternoon.
Good afternoon.
Good afternoon. Yeah.
Good. Perfect.
There are, for your information, maybe there are some material who are already in the website of LP2M. I send you the link in the chat room. Then,
okay.
but it is not yet complete. I mean, for all participants, we have actually also sent an email, if I'm not mistaken, Bu Endah. But it is not yet complete. So by the end of the seminar, maybe ya, Bu Endah ya.
Oh, okay. Marlis is joining as panelist. Hello, Marlis. Can you hear me?
Now, okay. Yeah,
Okay.
now it's better because I've tried several times and I had only the view of the participants, so who only can listen and can say nothing. So, but now I can see the whole features. So now I'm okay.
Okay, thank you for raising your hand so I can notice, oh, you're here now.
Yes, it's all fine.
Okay, still 86 participants joining. We will start at 1 o'clock Indonesian time. So we still wait, okay? Now 12:42, around 15 minutes to go, I think.
Yeah. maybe we can perform a short test. I will try to share my screen just to see whether this is operating. I mean,
of course.
it could be, but you never know.
Yeah. Yes, of course, please.
So you should now be able to see my PowerPoint.
Yes, I can read your PowerPoint.
And you should now also see my pointer moving.
Yes, red one.
Yes, a red one.
Perfect.
Excellent. Perfect. So then we are fine. Okay, I will stop sharing, and then we are fine.
Maybe Marlies, you would like to try?
I also want to try it. Yes.
Okay.
So, where's my presentation? So I think it's not there.
Okay. You have to find it first.
One moment. So, okay. I think it works.
Yeah. Yeah, I can see it.
Okay. So, and then when I want to go out, I go to stoppen. Okay.
Stop sharing. Yeah.
Okay.
Perfect.
So, perfect. Thank you very much. Terima kasih.
Sama-sama.
Yeah.
Okay, the participant is raising around 93, 92, and still raising. I already announced to the other participant that we are going to start this webinar, today's webinar at 1 o'clock Indonesian time. So we still have time. Okay. Marlies, do you have something to say? Sorry.
So no, it's okay.
Okay.
Did I raise my hand? No.
No, like before, like you have something to say.
No, it's okay.
Okay. While we are waiting for the others to join, maybe you have something to share or something? Maybe from Anche or from Holger or Marlies?
So I have to put my microphone on.
Yeah.
Did you get some feedback from yesterday?
Oh, what do you mean by feedback? Actually, some say that it was super. The topics and the speakers are great.
Good for Antje and for Prof. Dafik.
Yeah.
Yeah. And what about the composition of the participants? Are there in the majority students?
No, I think most of them are lecturers as well as researchers, but I'm not really sure actually because in the registration form we don't put the profession there. I think just the. Let me check. Otherwise, I'll make mistakes.
Yeah, and the electronic certificate, is it something to get for the students, or is it also important for the lecturers?
Available for all.
Oh, okay.
For all the participants here.
Mm-hmm.
But I can say that not only from the lecturers from University of Jember, but also from other regions in Indonesia as well. So we call it from Sabang to Merauke. So from the very east part of Indonesia to the very west part of Indonesia.
Yeah. Okay. Mm-hmm. And you have another background today. So you are in your home office.
I'm in my office because I'm sorry, I forgot to wear this white hijab. So when I put the virtual background, yeah, just not contrast, so like a ghost, right? So I think it's better if I don't put virtual background.
Yeah. But it looks very funny and entertaining. I mean, it's amazing what computers all can do, right? I mean, it's just so you are the good ghost or spirit of the whole event. So you are.
Yeah, it's funny.
But when I have a look on Bukatika, I see she has also a white here.
Yeah, she has a better notebook than mine, I think.
No.
Yeah, but she also had a little. It is not just white, right? There is some maybe that helps to the computer.
Yes. Yeah. If I move backward, you might not be able to see me.
Yeah,
to see you.
So maybe if I wear some glasses, maybe my eyes will be kind of like.
Yeah.
Yeah. So, but
actually, I'm
in
sitting
office
at the same place like yesterday, but yesterday I wore yellow hijab, so it is contrast. Now it's white, so it doesn't work. Okay, around 100 people are attending.
Yeah, today people are later. I mean, yesterday it was the first time, so everybody wants to be in time. That's normal. So everybody says, "Oh, maybe they had technical problems. You never know. You have to be in time."
Yes.
And everything went perfect. And then the next day, it is always the same with students, and they are always late. There's 2 minutes to go. Fine, I can log in. Everything worked yesterday. I don't have to be in time. And then everybody tries to log in within 5 minutes, and then you get the problem with the system because they are all rushing in at the same moment. But and this is what I learned from online teaching.
Yes. Yeah, we can see that the participant is raising a lot.
You see, it's the last minute.
Yeah.
Last minute, we still have 8 minutes to go. So.
By the way, to all the participants, I would like to remind you that we have a multinational participants for this webinar. So we would like to ask you to use English, please, not Indonesian. Okay, thank you. Sorry, chat. Sometimes maybe they forgot, right?
I don't will talk Bahasa in English. I can't.
Maybe you can learn from the chat feature. Some participants are writing in Bahasa Indonesia. For your information, ladies and gentlemen, we are not providing the list of attendees, so we would give you the feedback form during the webinar, so please stay. And once you have the fill the feedback form, so you will have your e-certificate directly in your email. Thank you. So please don't ask us about the attendee list again, okay? Thank you.
Presency, it's the common way.
Yeah, I maybe have a related question on coming together in those Corona times. So did you have kind of virtual meetings within the study program so that the teachers could meet and discuss how to use all the software and something like that?
Yes, yes. So we have not regularly, but you like the head of department always invite us to have a discussion on curricula, for example, because from this year we have a new curricula which is called as independence curricula, so curriculum merdeka we call it. So about that, so we have to somehow adjust, and for that, because we cannot directly meet each other, so we use this kind of meeting as well. Not only for the lectures, but also lab meeting, we do it online. But because the students until so these last 2 weeks, we are a little bit opening the lab. So for the students who are really need to do their lab work, then with the certain situation, you have to be aware about that they can go to the lab. But for the previous days when there is nothing at all in the lab, so we do kind of lab meeting only for discussing about like journal, but not as often as usual. That is because for the online teaching itself, for the student is also, how can I say, some of them might be able to get a good access because they live not in the remote area. But if they live in the remote area, you know, Indonesian is a island archipelago with mostly islands, so some of them unable to attend the meeting. So sometimes, as Anja said, it is really good with the voice notes so that they can download if the the signal is okay, and then they could see anytime. Doesn't have to be online. So yes, like that. I think this month there are some meeting which already attended by the lectures offline, but still we have limitation, like not more than how many people, so like that, because you know, like here in one department we have 21 lectures. Maybe 21 in Germany is like one faculty, right? in our faculty we have around almost 100 lectures only, and the administrative staff, they also have almost maybe half of so 50%. So it's really so many people here, Indonesian. Every 5 meters there is person.
Yeah. So the faculty is actually 40 people. So that's
40 people. Oh,
yeah.
okay.
Yeah, but still, meeting in person needs an application, and you have to fulfill the rules, and you have to apply 2 weeks upfront. So, and the same we will hear that when we talk about the laboratory. So there's still a number of regulations in place from the government that, of course, we have to comply to, which is limiting personal contact.
Maybe, I don't know, in pharmacy, maybe Bu Enda can also explain about in the pharmacy, because sometimes, because I heard, I have friend in the other faculty, not from my faculty. She said that, no, in my faculty, everything is fine. It doesn't have to be so strict. Yeah, maybe it's also depend on the person. I don't know, maybe Bu Enda.
Yeah, in pharmacy, there is but like less activity, I can say. The research maybe just done by the students, but in a limited way. So we have limitations for the number of the students working in the lab just for their undergraduate thesis. Then they have to wear the face mask, not only face mask, like and also the face shield. And they have to meet the certain protocol before entering the lab. Yeah, they have to. They don't have the like. They don't have the traveling into other cities, and they have like temperature check, thermal gun, and they have to wash their hands regularly, like the standard protocol for COVID-19.
Okay.
I have an announcement for this today webinar. It's going to be stream live, and the link is I'm going to write the link in the chat feature. Okay. There was an error, I think, for yesterday live streaming. So the video were divided into 2 videos, and today we are going to, yeah, I already write the link for today's live streaming in the chat forum. So the participant can also check there. Thank you. Now it's 1 o'clock, Butika. Shall we start now? There are 116 participants, and I believe some of them are joining via YouTube channel. Okay, it's 1 o'clock now. We can start the webinar, okay? Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, and good morning for all the speakers from Germany. It's very nice to see you again, and thank you for staying in this webinar. And today, this is the second day of the webinar. The DAD bilateral project between Flensburg University of Applied Sciences and University of Jember, capacity building for research group, application of molecular biology and bioanalysis methods in research and its didactic approach for online teaching. The Honorable Director of DAD bilateral project between Flensburg University of Applied Sciences and University of Jember, Professor Dr. Angela Bes, the coordinator for University of Jember, Dr. Renat Kartika Sunjarini, the respectable speakers, Diplom Biochem Holger Reman, and Diplom in Marlis Vitae MSc from Flensburg University of Applied Sciences, and distinguished guests. Thank you for staying here with us, and I will have something to inform you before we start this webinar. I would like to remind you again that this is a multinational webinar, so we are encourage you to speak in English, not in Bahasa Indonesia. And we are setting this webinar into webinar mode in Zoom, so the attendees could not speak or show their video unless we are give you the permission. So I think it is more convenience for all of us. Otherwise, we will have like certain sounds or something like that that might disturb this agenda. And we have the Q&A feature. If you have something to ask during the discussion, please use the Q&A feature, while the chat feature just for like ordinary information. Today we are going to have two speakers from Flensburg University of Applied Sciences, and still moderated by Dr. Renat Kartika Sunjarini. Okay, Bu Kartika, time is yours. Thank you.
Yeah, okay. Thank you so much, Bu Enda. I think you can hear my voice clearly, right? Yeah. Okay. Good afternoon once again, ladies and gentlemen, all of the participants for today's, the second day of webinar. We meet again for the second day, which will be focused on how we implement, especially what we learned yesterday theoretically, and today, how can we implement all those theoretical things into teaching and especially into lab practice. Because previously, before the pandemic, I could imagine to do the teaching online, but I have never expected that we really have to also improvise ourselves, that we have to do somehow even lab things also online. So, and this is what we wanted to share between Germany and Indonesia, because this is also one objective of this collaboration, where we can share about the experience, how you do there in Germany, how we do try to cope also the situation here in Indonesia. So now I don't want to lose more time, and directly we have, as mentioned by the MC, that we have two speakers. So the first speaker will be a Diplom Biochem Holger Reman. He will talk about the bioanalytic as an online course and its application on corona detection assay. So now I will give the session to Holger. Please, Holger, you can start the presentation. And later on, we will have a panel discussion after the second speaker. Yeah.
Okay, thank you for this Nice introduction. And now I see that Okay, I hope you can all see my screen, which is shared. And you see my pointer? Good. Well, thank you very much for the invitation. And I'm very happy to be here today to talk to you about our experience in teaching during Corona times. Well, I put now a very short title, Teaching Corona Online. And as you can hear from this title or read from this title, there are basically two levels in this title. One thing is, of course, how do you teach in times of Corona? But the other thing is, how do you teach Corona as a subject? Because I had to teach a course in Bioanalytics, which was in the higher semester, so at the end of the bachelor program. And then I thought bioanalytics, if you would like to detect a virus, this is a typical bioanalytical problem. So just be actual in time and do something which is timely and discuss with the students or use the example of the coronavirus as a bioanalytical problem as an example to prepare and to develop the course. And I have to say that I joined the University of Applied Science in Flensburg just in February. And when I started, I informed myself, which lectures do you have to give? And then I learned, okay, you have to teach bioanalytics and you have, and so on. And I thought, okay, I just prepare my lectures as you normally do that. But this was in February. And then March started, and normally mid-March we are starting with teaching. But then just mid-March, Corona started. And basically there was no normal start in teaching. So from just trying to set up my lectures, I very briefly had to switch it to a kind of compatible online Corona modus. And that was, of course, at the beginning a little bit, stressful because we had to learn how to do that. And we had to get experience to how to do that technically. But on the other hand, I also had the advantage that I was new at the university. So I had to teach the courses for the first time. So I couldn't use all my material from the years before. So I could easily say, then I just prepare something new and just be open to whatever is possible during Corona times. Yeah, so teaching Corona online. And as I mentioned, I decided to use the Corona as an example for teaching. To get the students a little bit motivated, to be happy to do something, even if there is Corona. And I am now able to switch the slides. I'm not. So now we have to stay on slide 1, which is not optimal. Let me quickly stop sharing, and maybe I have to go back. I'm very sorry. Maybe the problem was it was all. This now works on my screen, but I think now you don't. Okay. Share screen. And yes, now it works. So you see there is still stuff you learned. So we did the screen sharing test, and then I went into the presentation mode, and then I left the sharing mode. And for whatever reason, when I was going back directly in the presentation mode, it is not able to flip the slides anymore. Okay, so you see there is always new stuff with these online tools. Anyway, so when I was preparing me for the first lectures I had to give, I thought there are different possibilities, and what is at the beginning the easiest with the little technical demands and with the little stuff you need, and this is to give the students a kind of assignments. And I mean, this is what you are maybe doing more frequently, that students get assignments. But I thought, okay, if they cannot come to the classroom, and maybe we have problems to give real online lectures. So the assignment should be built up in a way that the students can learn a lot of stuff what they normally also learn during the lecture. So not just, normally you give a lecture maybe, and then you make an assignment for the student, and the assignment is a little bit to test whether the students picked up what you have taught them during the lecture. But now there is no lecture, so basically you have to make the assignment such that while solving the tasks, the students also learn what you would normally teach them during the classroom, during the normal lecture. And maybe you already got that. I provided you some example of the assignments which I distributed to the students. So maybe some of you, if you got it already, flipped through it, because it's a little bit difficult to show that on PowerPoint. It's provided as PDF and it's normal text document. So if you just put it on PowerPoint, this would not be very didactical, very wise now, because you can hardly read it. But I will briefly guide you through it. So I thought, let's start with an assignment for the students. And because it should be, and before I start with examples for the assignments, I will give a little summary about the typical teaching situation which you are facing. So normally you have on the one hand the student, and on the other hand you have the teacher, and the teacher tries to provide information and content to the student. And one thing what you are teaching is, of course, facts, because students have to get a certain factual knowledge. And these facts can be simple. For example, it can be the velocity of the light, but it can also be information like how is the biological membrane of a cell composed, so what is in this membrane, or you can introduce to students, if you are talking more in chemical terms, or if you're teaching chemistry, what is an isotope. So this is basically more or less factual knowledge, but to some extent students knew that. But on the other hand, what you also would like to teach is, and which is maybe even more important, or at least intellectually more important, is that you teach concepts and understandings and capabilities. And for example, you would like to teach the students how to do DNA sequencing, how to use mass spectroscopy, how is the immune system working. And this is much more than facts, because the students have to understand. They have to understand concepts, they have to learn, and they have to be able to apply the knowledge they learned. So you need a combination of both. And both you are providing to the student. And on the other hand, you get feedback as a teacher from the students. So this is normally a kind of question. So students ask you, oh, I didn't understand that, or I didn't understood that. Or could you maybe elaborate on this? And if you're now doing this all online, or if you're giving them assignments, then basically you are losing the feedback. So you are still able to communicate to your students, but you don't get the feedback reaction from the students. So you have to deal with the situation that you have to find a way that you get feedback from the students. And if I'm saying feedback, this can be very simple. Just imagine a normal classroom situation. You are seeing your audience, and then often, or maybe sometimes, depends on how good you are as a teacher, you have a situation like shown on the screen. So you immediately recognize that you lost your students, right? So they are sleeping. Well, maybe sometimes students do that. But even if they are not sleeping, you realize that they just don't understand what you have just tried to discuss with them. And if you have the situation, then you stop a little bit your lecture, you are not continuing, you repeat something and you solve the issue, and then you can continue. But if you are now doing this online, you don't have this immediate feedback. And this is just little feedback, just what you see on the faces on the student. So you have to deal this out. And just to discuss the situation a bit, so you as a teacher have a brilliant plan how you teach the subject to the students, and everything is logic to you. So you start with A, and then B is logical, and then C is logical, and D and E and F. So it's all very clear, and you would like to present that to the students because they should understand, and they should understand how you are doing that. But maybe you are losing your student already after you are arrived at B. And then you are continuing with C and D and E and F, and you consider is fully logical, but the student you lost here. And that means this was maybe quite at the beginning of the lecture. So all what you are doing in the rest of your lecture is basically waste of time, because you are talking and you are presenting your brilliant ideas, but you lost your students just here. And sometimes the reason why you lose a student can be very simple. And I put an example here. If you are talking about, let's say, molecular biology or bioanalytics, for example, the teacher might use the term primer and oligo more or less with the same meaning. He might have a little different meaning. So sometimes he uses primer and sometimes he uses oligo. more or less, very simple, you can say it's as synonymous. You can use them almost with the same meaning, at least with the first approximation. But this teacher uses both words. But the students may only know primer. He never had heard the term oligo. So whereas the teacher, for him, it's totally logical. He sometimes say primer, he sometimes says oligo, a little bit dependent on the context. But the student is only fine if he hears primer. But as soon as you say oligo and you think everything is clear, the student is lost, not because he is not understanding a concept, just because he is not realizing that for you, primer and oligo is the same. And that means the student once has learned the term primer, but he never really learned the term oligo, and so you lost him. And if you have this in the classroom situation, you realize that you are losing the student here, and then you can easily fix this problem that they don't know what a primer is or what an oligo is, or maybe they just ask that. If you do that online, you are losing that, and then you are lost for the rest of the time of your lecture. Or let me give you another example. If you talk about an H+, you also call it a proton. This is quite common in chemistry. So you just say a proton was dissociated and so on. But for a student, he often gets first a course in chemistry, and then he learns about ions, he learns about H+. And this is the same for him as a, let's say, a potassium plus or a chloride. And of course, you know that if you say H+, it's chemistry and you know what you mean. And you write H+, but you say proton. But the student never learned the term proton to use for an H+. For a student, a proton is something which has to do with nuclear physics, so with the nucleus of whatever an atom. But you never realize that in chemistry, if you talk about an H+, it's formally just a proton. So for the students, these are totally two different worlds, the world of chemistry and the world of nuclear physics. And you are using terms from both worlds, just interchangeable in your lecture. You are writing an H+, which the students understand from its chemical lectures, but then you say proton, and the student thinks you are talking about nuclear physics, whereas you are just doing your normal biochemical lectures. And these are those little misunderstandings, which can, in particular, if you don't get the direct feedback, result in a lot of misunderstanding. So you have to find ways how to deal with that. And I mean, of course, this could also be a general problem in teaching, but how are we doing that? And I mentioned that I first started with give the students assignments. And so I gave them assignment 1 or assignment 0. So this was even before the real assignment. So this was a little warm up to get an idea of what the students know. And the idea was, so we are dealing with Corona. We have the Corona pandemic. So we would like to be able to detect the coronavirus. So how can we measure that? And so therefore, I just asked the students the question, how would you develop such a test? Consider how to measure the virus. I mean, this is a typical analytical problem. You would like to measure something, right? I mean, this is where all analytical processes comes to. So you would like to measure something. Which analytical method do you suggest? And which specification should be met if you develop the test? So that the students think, in one hand, in general terms, they should learn if you have an analytical problem, how can you solve that? How can you come to a solution? How can you find something that you can measure? I mean, you would like to measure the virus, but this is the thing you would like to measure. But of course, you have to find a signal which is somehow related to the virus, which you can detect. And at this way, I could also get a first impression of what the students already know and how what ideas they have by themselves. And as I mentioned, this was a course for students in more or less bioanalytics, which were at the end of the bachelor time. And then it was very interesting to see the answers of the students. And this is shown here. So almost 80% of them suggested that one should use some kind of PCR technique. So basically it was a kind of qPCR. But you also realize from what the students were proposing that on the one hand, they to some extent know what a PCR is. And they also had heard the term quantitative PCR, but they were not really familiar with it. So sometimes from the answers you realized, okay, they know briefly what they want to do. They had a rough idea, but they didn't understand the details. And there are some stuff where you directly realized, okay, this will not work in practice, how they are proposing that. And maybe there's also stuff what they picked up from the media discussions. And you also frequently got the answer, we can use antibodies, and antibodies, we will come to that later. And some of them proposed electron microscopy. to detect the viruses. And then there were also some other methods. Some of these other methods they propose, well, I would say they're not really feasible, but the students put a lot of, some of them put a lot of fantasy in it or a lot of thinking. So they came up with all kinds of ideas how you could detect a virus. And I mean, even so, this was maybe not something which would ever work in practice. Some of them came up with a lot of ideas how to prepare controls and how to check and what to do. So even so, it was not feasible in technical terms. At least they were thinking as scientists that they need controls, that they have to check, that they had certain limitations. So this is a positive aspect. So you have to find a way to come now with these ideas to streamline this first into what they should normally learn, but also to get that down to what is technical doable and how you would normally detect such a virus. And so if you are talking about making a qPCR, and this is at the moment the standard test to detect the virus, so all the virus tests which are now on the market or which are used by the governments, this is in principle just qPCRs. And I think you are all now you are all familiar with this technique, so I don't want to go in detail with that. I mean, we are not giving a lecture now on qPCR, but we are more giving a lecture on how to teach qPCR and how to teach this kind of bioanalytics in the context of Corona. And I think what for us is very obvious, if you have the coronavirus or the SARS-CoV-5, then you know that this virus doesn't contain DNA, it contains RNA. This is already something which for the student is not obvious. So they are not thinking of, oh, if I would like to use qPCR, do I have to start from DNA or do I have to start from RNA? For them, it's just, I would like to detect the virus and I would like to make a PCR. And then I somehow use the DNA and then I somehow end with my signal. But it's not the first question they are asking, oh, is this RNA as target or is this DNA as a target? So you have to help them and to guide them that this is an RNA virus, and that means that you first have to go for a reverse transcription. In principle, they, to some extent now, these concepts, but they are not realizing that this is the first important question you have to distinguish if you would like to tackle your analytical problem. And then you go on, so you have your DNA polymerase reaction, and of course they know how to DNA polymerase reaction works, but we will later, I will show you examples that they understand the basic concept. But on the other hand, that they also have problems in realizing certain consequences. So you are ending up, let's say, from the RNA to your signal. And then the other thing, which is very interesting also, people suggested antibodies. And of course, most of them, or often, they knew what an ELISA is. So somehow in previous courses, somewhen, they learned what an ELISA is. And of course, theoretically, you could detect a virus also in a traditional ELISA setting. So that means that you use an antibody against the virus. So this is very general speaking. Of course, you would not use the whole virus, which I'm depicting here. So you would like to use a part or a protein, a certain protein of the virus. And then you are just detecting this protein of the virus in your traditional ELISA setup. This is what indeed students proposed. This is, by the way, nothing what you are doing. So technically, this is not how you are detecting the virus. So you are not using an ELISA to detect the virus itself as a particle or parts of the virus to detect whether the virus is present. You are not doing this. This is not sensitive. This is not working. So they are not this kind of ELISAs which are developed and they are not on the market. And I think it's also not a general technique to detect viruses in general by using a ELISA setup in this setting to screen the population. This is what students cannot know. But I mean, at least they come up with this concept. And I mean, as you, I think, all know, there is also a lot of attention in the media that in principle, you would like to use antibodies to detect the virus. I mean, there is a lot of discussion about antibody tests. And indeed, to some extent, also some of the students understood and grasped this concept on forehand. So you are using, in the end, also again an ELISA setting a little bit. You can compare it, but you are not detecting the virus or virus particle itself. What you are doing is you are detecting antibodies the infected person has raised against the virus. This is, of course, also a way to measure to some extent the virus. I mean, the virus causes a person to generate antibodies, and then you're detecting the antibodies. So in the end, you are also getting information of the virus. Of course, it could mean that the virus is long gone and that the antibodies are still in the blood of the patient. This is a normal immunity, of course, but this is also an analytical problem. I mean, you would like to detect the antibody once raised against the virus in the patient as a diagnostic test tool. And so then basically you are teaching the students, okay, the patient was infected by the virus, you take a blood sample, you isolate all the antibodies, and of course the patient has more antibodies than just antibodies against the coronaviruses because he is in contact with all kinds of stuff. And so there's a lot of antibodies. And so then you make a setup like this. So you immobilize a part of the virus, you trap the virus-specific antibodies out of the blood of the patient, and then you use the anti-human IgG antibody as your secondary antibody to detect your antibody, which was generated against the virus in the patient. So a very simple traditional setup. I think as a teacher, you all directly understand what we are doing here. But for the students, that you have an antibody which is working against any antibody is something which is quite fascinating and uncommon. On the one hand, you always teach them you have different antibodies. They are all different. One antibody recognizes this part of the coronavirus. The other antibody recognizes this part of the coronavirus. And then there are antibodies who are recognizing a bacteria. And then there is antibodies who are recognizing whatever. And you are discussing how the antibodies are generated, that you have the monoclonals, that you have polyclonals, that they are highly variable in sequence in the hypervariable region, so that they are all different. So you are discussing that with the students. But then you have an anti-human antibody, well, at least anti-human IgG, so one class of antibody, but that you have basically one antibody who can detect a lot of other antibodies. And this is for you quite clear. And you, of course, and this is what you're also teaching your students, that there is a part of the antibody which is common and that you have the hypervariable region which is different. And you think everything is clear. But then, so this is now a little bit what you did later, and this is what I did later on in a test. I asked the students, well, you learned about an ELISA or about immunological detection methods. Can you now design a test to perform a pregnancy test? And this is a traditional ELISA example. I mean, this was one of the first ELISAs on the market. I mean, the students are young, so they don't know that. But I mean, that was when ELISA were first becoming, let's say, public and recognized by the public with pregnancy tests. And so you teach the students, I mean, this is what you give them as a task. You tell them, okay, the task is that you have to find a way how to measure human chorionic gonadotropin, so the hormone you get after fertilization. And this is in the urine and in the blood of the female who is pregnant. And then indeed, the students suggest, we can use an ELISA. We need an antibody against the human CG. And then we trap from the urine the human CG. And then we need an antibody to detect that. But then, and many, so more, it was not just one student. So independent students came up with the idea. Then for the detection, we just need an anti-human protein antibody. So they use the same concept they learned before, that you have an anti-human IgG antibody, so a general antibody, which so to say detect basically any primary antibody here. They just transfer this concept to that you can have an antibody which just detects any human protein. So they understand the concept that you need one specific antibody, which is specific for the human CG, but then they believe that you can come up with an antibody which is detecting any human protein. I mean, on the one hand, they try to understand and they try to transfer knowledge. On the other hand, as a teacher, you realize this is something which will not work. So there is no general antibody for all human proteins, right? So you think it's logical. So you have to explain that and you have to go a step back and you have to discuss this with your students. So this is a very interesting situation, how you think you teach a concept and what the students make from such a concept. Well, let's continue. So you have PCR, you have antibodies which the students suggest, And then students also suggest electron microscopy. And then one student put as a comment, PCR is cheaper, but it's very time consuming. I therefore consider the observation of the virus by electron microscopy to be more appropriated. So the student thought, he was really thinking, what is the best way to detect the virus? And he knew about electron microscopy. And of course, you can use electron microscopy to visualize coronaviruses, and they are used to analyze coronaviruses. But you would never use an electron microscope to detect the coronavirus as a diagnostic tool. And you also now, you cannot in an electron microscope distinguish between a particular coronavirus from another particular coronavirus. This is just not a tool to screen a cohort of patients to use electron microscopy. But somehow the students have the idea that an electron microscope is used like a normal microscope you maybe use in, let's say, microbiology, a normal light microscope where you do a quick test like a gram staining or whatever. So they have, in the end, no idea what an electron microscope is technically. But this is also, how does this come? And if you think about this is because there is a lot of bad communication on science. I think you all know these pictures from common media. So people on the television, in newspapers, you always see this kind of pictures, which are also provided by scientists, which are considered to be the coronavirus. And these pictures, they are nothing. They are just Hollywood. They are just making the computer. They are animations. They have basically nothing to do with science, or not much. They are a cartoon. And of course, you can say that a cartoon has something to do with reality. But if you are looking at a cartoon, you don't believe that humans can act like figures in a cartoon, at least not literally, right? They can teach you something, but this is a cartoon you find in the media. But what students assume is that this is a picture you see under the electron microscope. So they really think that you see something like that. And sometimes you have this animated stuff, which is really like a movie. So they really believe that this is a movie type taping from an electron microscope, where you see something like this floating around, somehow docking to a cell and infecting the cell. So that means you have to teach the students slowly what it means if you make an electron microscopic study or a picture. So for example, you can first show them a picture like this. So this is the real picture, more or less, you get from an electron microscope, which is already to some extent processed, of course. This is a complicated technique. But then as soon as you have color in, any color in an electron microscope picture is just fake. It's just added by a computer. It's just interpretation. So here, this is an example from a bacteria. So the bacteria is shown in red. And then students see these pictures also in textbooks, where they see, and then you have a heading under the picture. Oh, the bacteria is red, or it's colored in whatever this color is. But this color was just an interpretation of the scientist. So he just marked in a complicated color scheme what he considered is the bacteria. But it's not that you can distinguish and that you recognize the bacteria as something red under the electron microscope. You have just interpreted this black and white data, and then you believe that the bacteria stops here, and you just tell the computers to stop at this point with the red color. So this is something you then have to teach your students, and you have, so to say, bring them to the background of electron microscopy. And you also have to teach them that you cannot just take a sample and put them under the microscope. Under the electron microscope. Normally you need a negative staining, for example, or you have to go for freeze thawing. So there are all kinds of complicated techniques. But normally you have to add, let's say, gold staining, or you have to use platinum or whatever, but you have to put a little metal film over your sample. This is all something students normally at the beginning don't realize if they are talking about electron microscopy. And I think, you are aware of it. And now I don't want to start with a lecture on electron microscopy. You're running the risk that I then talking for the next 2 hours just about electron microscopy techniques, which are, of course, very fascinating, but what we are not doing today. But these are the things what you are realizing if you just ask the simple questions to students. How would you like to detect the coronavirus, then you realize that students have a lot of ideas, but you also realize what you still have to teach them and what they understand, but also how do they understand things. And so this was an assignment how to prepare students, so just to warm them up. And I asked them directly within a few days to send that back so that I could get already an idea, let's say, on what level they are and what they are doing. And then the next assignment was, so to say, Corona by the Charité. And maybe you are not familiar with what the Charité is. So the Charité is a famous hospital in Germany, and you can say it's a German national laboratory. So if there is something with infectious diseases, then there is a lot of capacity and a lot of knowledge at the Charité. And this is where you handle that. So they, for example, also have an S5 laboratory, so they can really handle anything which is infectious on the highest level. And they have a very strong medical background there. So it's a very traditional clinic. And of course, the scientists at the Charité in Germany, so they were dealing with the corona outbreak, and they were also publishing also via the World Health Organization a protocol how to detect the coronavirus by a qPCR test. And this test was made available to the public also via the World Health Organization. So this is where this document comes from, already in January 17th, 2020. So and you got this information also in the teaching documents I provided. So I provided the students, it was a PDF document, let's say 5 pages. And on these 5 pages, these scientists at the Charité described how they used RT-PCR to detect the coronavirus. So this was real life. So this was reality. So this was not just a textbook example. I just took something what you have normally, how scientists communicate with each other. I just gave them well, it was not really a paper, but I mean, it was published, but not in a journal, but made available via the homepage of the Charité. And also it was made available via the World Health Organization to the scientists worldwide. So this was the information you have to deal with if you are a real scientist, if you are at the, let's say, forefront of corona research. So you're getting this information that scientists at the Charité and also other scientists, of course, they published similar protocols, how they detect with qPCR the virus. And so then you find all kinds of information, which primers are used, what kind of quality controls were done, and so on. And for the students, of course, they don't know what kind of quality controls you have to do, and they are only partially familiar with qPCR. So that means for the students, it's of course not easy to understand this document. And of course, I also mentioned that to them. I told them, try to understand this document. So to say this is what comes from the, let's say, real world. It's not just a textbook example. This is, you are getting something. So it's a German saying, you are jumping into the cold water and you have to learn to swim. But just try it, just have a look, and you will be able to understand a lot. And there might be things you will not understand, but just try to address your questions, make an annotation what you don't understand, and also try to understand it. And maybe you can find other information which helps you to understand what these people provide you as information. And so the students went through the document and they grasped that they were doing a qPCR. And they were also understanding that you first test mRNA and that you had to make a reverse transcriptase. And they also understood the problem that there are other coronaviruses which are quite similar, which you have to distinguish, and that somehow the scientists were discussing how to distinguish the, let's say, COVID-19 corona viruses from other coronaviruses. They didn't always understood all the details, but they understood the general concept and the general problems. And then from what they were discussing, so I also asked them, what do you think could be a problem if you go for these tests? And then, for example, the students say, errors introduced by the polymerase would be a cause of concern because this would result in false positive results. And I mean, this is typical. I mean, the student is thinking, so he's thinking what can happen. And of course, students have learned before about PCR. And if you're making a PCR, you teach your students, well, there can an error occur, so the polymerase can misincorporate the nucleotide. This is what you're also teaching them in biology, for example, if you are telling them of how mutations can occur. So the students somehow really think, okay, if there's a problem with the polymerase, if there is an error, then we have a problem. But be realistic. If we are making a qPCR, who cares if there is a mutation here by the polymerase? It doesn't matter at all. You are just amplifying. So the primers have to bind. There has to be selectivity, and they should not bind somewhere else. And if then the polymerase from time to time is incorporating a wrong nucleotide, you are getting your PCR product for what you are detecting. And whether this sequence here is erroneous or not doesn't matter at all. As long as your prime specifically only for your coronavirus DNA, you will not get a false positive result because the polymerase is inducing an error at this point, right? I mean, for us, this is clear. If you would like to sequence later on your coronavirus, of course, it is a problem if your polymerase is introducing errors, because later you are sequencing the PCR amplified mRNA or DNA or whatever. Then, of course, polymerase errors are a problem. But in the context of a qPCR, these errors are not an issue at all. So this is something which students have to learn and which they have to understand. And this is also something in the end what you would like to understand students, because if they really understand the concept of qPCR, they know that if the polymerase is making an error here, that this is not a problem for the result. This will never result in a false positive result. The only thing which makes a false positive result would be if your primer is binding somewhere else and resulting, let's say, if there is a similar viruses which is also recognized by the primer. So this is what students have to understand conceptually later on if they really would like, as a scientist, using qPCR and like to discuss and understand what the problems are and what they have to consider and how to develop such a test. So I found this an interesting example. And then students say, well, I'm expecting 2 bands because the student suggested the qPCR to analyze it on an agarose gel. I mean, you can do that, of course. I mean, nowadays there are more modern ways of doing qPCRs. You would normally do a real-time PCR, but I mean, you can analyze it on an agarose gel. Nothing wrong with it. And if you start with an agarose gel, that is also very useful didactically, because this is a very simple concept and this really shows you what you are, so to say, generating as a PCR product. So in that respect, starting first with analyzing a qPCR with an agarose gel is very helpful, even though you would never do that in a diagnostic laboratory, that you analyze your patient's PCR reactions on an agarose gel. I mean, you would always make real-time PCRs nowadays. I mean, that's but for didactical reasons, this is interesting. And you start maybe also with this gel example. But then, I mean, so it doesn't make sense that you have 2 bands, one for human and one for virus. So on the one hand, the student somehow understands that you are amplifying something, but he is not realizing that you are ideally designing primers which are specific for the virus, and that you will get somehow a PCR product which you detect on your gel which is for the virus, but that you are not amplifying the whole genome of the virus and that you are not amplifying the whole genome of the human. I mean, just think about that. I mean, for us, it doesn't make sense at all, right? I mean, the human genome is billions of base pairs and the virus is something like 5,000, whatever. But you would never amplify this whole genome and then get just one big band, just one big molecule of DNA for human and one big molecule of DNA or much smaller, whatever, DNA for the virus. So basically, you have to teach the students later on, well, this is a little bit different. You are not amplifying the whole genome of the human and you are not amplifying the whole genome of the virus. You are just amplifying a very short part of the genome and you are only amplifying one short specific part of the genome. That is how you are distinguishing. And so, I mean, from getting this kind of answers from the students, I designed the next assignment. And in that assignment, I wanted to guide them more to qPCR, and I wanted that they try to better understand how this is going. And you can, I mean, I provided you with this assignment, so you can also have a look at that, how I try to guide them stepwise to the different procedures of qPCRs, and that they also should, so basically I always ask them, imagine that you are doing this, let's say you have this and this DNA fragment, and you are adding this and this primer, what do you think is happening? And then students can can find that out. So to say they make a Gedankenexperiment. I always like this German word Gedankenexperiment, which makes it into the English language, so that you are just doing the experiment by your thoughts, that you are just doing it in your brain. So Gedankenexperiments can be very powerful, as it can be very useful for students if you ask them, well, just think, what do you expect? You have this situation, so what will happen? And for example, I hope you can read that a little bit. I gave them this as an assignment, as a task. So I provided them with 3 DNA sequences. You don't have to read them. I mean, they are too small. And I also provided them with, in total, 4 primers. And the primers were just ordered in random. And then I asked them, can you figure out where the primers are binding to the DNA? And for example, primer 1, I think primer 1 was this one here. So people would recognize that it is binding here. So they had, I put this in bold. I think you can recognize this still. So when people were analyzing the sequence, and they had to analyze the forward sequence, and they had to analyze the reverse sequence, they were able to assign the primers to the DNA fragments. And then basically what the students should realize is, that was my intention, they are 3 DNA fragments, and they are all present in your PCR test tubes. And you have added 4 primers, but you have no primer which binds to fragment 2. So that means you will get a PCR product for fragment 1 and for fragment 3. So that means, and this is a principle how you use to specifically detect one specific DNA sequence on the background of a lot of other sequences. Let's say you have DNA originating from the coronavirus, and you have all kind of human DNA around, you have all kind of bacterial DNA around, whatever. I mean, just a normal sample you take from your patient, you have a huge amount of DNA of all different sources, but in the PCR, you are only amplifying one specific sequence determined by your primers. And this is theoretically what the students should understand from making this Gedankenexperiment, because they should realize that fragment 2, that this DNA is present, but not picked up by the PCR reaction. And then if you continue, and if you ask them to draw a picture of an agarose gel, how this PCR would look like, ideally they should recognize that you get a bigger fragment from DNA fragment 1, because 1 primer binds here and the reverse primer binds here, and that they get a shorter fragment from DNA fragment 3. So basically, they should learn and understand from this example that if fragment 1 is present, they get a certain size of a DNA fragment on the agarose gel, and that they get a different size of an on the agarose gel if fragment 3 is present. And you can choose by the design of your primers how big your DNA fragment is. So that means you can generate a signal that is the size of a DNA fragment, which is specific for fragment 1 or for fragment 2. Let's say a size of 200 base pairs would then be specific for the coronavirus, and the size of 100 base pairs would be specific, let's say, for the DNA of a monkey. So that means if you get a size of 200 base pairs, you know coronavirus is present. And if you get a size of 100 base pairs, you know monkey is present, monkey DNA is present. And in this way, students should understand from this simple experiment, if they are just thinking of what is the result, what is the outcome, if I'm doing this PCR reaction, if I'm trying to figure out where the primers are binding, what is the outcome? And most of the students are somehow able to manage that. So this is, I mean, normally you are providing a lot of this information during the lecture. And now the idea was that they are picking that up during the PC, during the assignment, so doing this Gedankenexperiment. And then, I mean, there were more questions. So, for example, I asked them to determine the number of copies you have, let's say, after 30 cycles of your PCR reaction, if you have started with 1, 10, or 100 molecules. And most of the students, or some of them, are able to calculate that. So they are coming up with the correct formula. Interestingly, a lot of them just say, oh, if there are 100 molecules, I have to calculate the number of molecules to the power of the cycles, which is, of course, mathematically totally nonsense. But they are not realizing that. So you're coming up with all kind of mathematically, let's put it this way, very interesting suggestions the students have. So, I mean, you in this way, if you are looking, I mean, they are handing in these assignments, you are realizing what they are not understanding, what goes wrong. But then they are coming also up with questions which you have not really thought of. So they are asking you, oh, if I say a copy and if I'm counting the DNA molecules, what is one? So this is a DNA molecule. So it has 2 DNA strands. So is this now 1 or do I have to count it as 2? I mean, this is a question. I mean, it shows you that the students really start to think about what is going on. I mean, it's in the end, it's a very simple question. Do you count the DNA molecule as 1? Or, I mean, 1 DNA string as 1, or do you count it as 2? Right? I mean, this is somehow, as a teacher, we are not really thinking about it anymore as a molecular biologist. I mean, we are doing PCR reactions or qPCR in our lab maybe on a daily basis. But this very simple question, I am counting it 1 or do I count it 2? Which maybe is even not so much of practical relevance, but from the theoretical point of view, if you try to understand it from the student's point of view, this could be a very important question. I mean, this is a student who is dealing and trying to understand the concept behind. So the general question, what is a copy? So I mean, it's interesting to see this from the perspective of the student. And you have also, I mean, this was what was provided in this document from the Charité. So an example of a qPCR. And I mean, as a molecular biologist, as a bioanalytics, you directly recognize this kind of figures, right? The raising signal with increasing number of cycles. But for the students, even so they described before how a qPCR looks like and how you are measuring it, and you were guiding them through how you are able to detect in real time a PCR. It's very difficult if they are seeing this kind of figure. What does this mean? What has this to do with what I had learned before? And of course, one problem is the quality of this PDF document they were providing was not very brilliant. So, I mean, it's not only the quality on this presentation, so you can hardly read this labels on the axes here. So this was a problem in the original document. So later on, I added it in bigger letters for the students. But for us, I mean, this is real life. So you're getting this kind of document from your colleague. And you immediately know, okay, this is a typical result of a qPCR. But the students are now struggling with trying to figure out first, okay, oh, this has to be the cycles, and this has to be the fluorescence, and this means, and I learned before how a PCR is working, and this is how it looks in reality. And then you also get, I mean, this was an interpretation of this data a student sent. Very interesting. So he say, oh, there is a lag phase, and then here there is an exponential phase. Mathematically, totally wrong. I mean, these students were totally spoiled by biology, by microbiology, where you have this growth phase of bacteria, where you have a lag phase and where you have an exponential phase. I mean, before you were teaching the students that you can easily calculate the number of copies. That is how you started with the PCR. It's doubling every cycle. Or it's not exactly doubling, but I mean, you can calculate it. And the idea is that you are generating a signal that from the amount of copies you are getting, you are calculating back by this simple formula how much copies were present at the beginning. So that means there has to be doubling with every cycle. And then the student tells you, well, the exponential phase stayed here. So if this would be correct, there would be now simple mathematical law how to correlate the amount of PCR product to the starting amount of DNA. It is doubling every cycle. And only if it's doubling every cycle, you can calculate back to the beginning. And that is what is happening, right? So you can calculate back because you know it's doubling. I mean, you don't see the signal really rising here because you are under the detection threshold, but you already have exponential growth there. And this is how you analyze the data. And this is a concept also which the students have to realize later on. And they didn't realize that here, by proposing this formula, they say we always have exponential doubling. We have exponential formation of the product. And then they say later on, oh, exponential starts later, and at the beginning we have something different. So, I mean, of course, theoretically this could be, but then you would have to come up with a totally different way of analyzing your data. So this is theoretically the student should realize. If they first say we have an exponential law, and if they then say, oh, this is not true at the beginning, that they cannot analyze the data in this way anymore. So either it's not true that there is a lag phase, or they cannot use their formula. But it is something, interestingly, students are not coming up with. And so, because you have this kind of little problems in understanding, I thought at a certain point it is difficult to sort out all these issues in giving them more assignments. So there should be also a kind of lecture stuff. So I gave them the assignments, and then I analyzed the data, and then I made a kind of online lecture. And I mean, this was technically sometimes a little bit tricky. So not all students could easily follow the lectures. They had problems with the data transfer and so on. So we were also taping these lectures. And in these online lectures, I was then discussing this kind of problems with them. So that was a more direct feedback. So I picked up the, let's say, problems they had in understanding. And then I discussed with them, how is the PCR working? What problems you have? How can you deal with that? So it's always exponential. If you would like to detect a spurt in DNA sequence, maybe first you have to go for the reverse transcriptase. If you would like to distinguish different species within one PCR reaction, you can make that by assigning, and so on and so on. So you are discussing that with them, and you are, so to say, you are from the, I don't want to say from the mistakes, but from the way how they learned and what they figured out, you help them further and you discuss with them. So you guide them further in the way how they came up with ideas. And you can also go a step further. For example, this is another example. So this was more an example for students which are quite good. So to give them some extra task. So, I mean, when you were just Googling, there were all kind of companies which tried to enter the market with all kind of corona tests. And I mean, some of these tests in the end, they are quite expensive and you can question whether they are really useful. Some of them are even not working. But this is a commercial system sold by the company Shepard, and in the end, it's just a qPCR. They are not really saying that, so you have to guess it from what they are saying, that in the end, they are doing nothing than a qPCR. And what they are doing is, so you have to buy this apparatus, which in the end is somehow a qPCR apparatus, which is relatively expensive. And then you have to buy these little cartridges, and then you put a sample in from one patient, and one is something like $150. And then you just put in one of these nose swabs from the patient, and then somehow in this cartridge, I mean, you have some solutions in which is extracting the DNA. I mean, you know what you have to do, and then this apparatus can make a qPCR. And then this cartridge costs €150. So I ask the students, well, imagine you are the head of a diagnostic lab, and the sales representative of this company is coming by and telling you, oh, I have a brilliant new machine for you, and you have now the problem to detect coronaviruses, and you should make a lot of tests. So now you should judge this kind of, I mean, are you buying this apparatus? So can you make a judgment? Is the price justified? Are you convinced by the throughput? And I mean, if the students are good and if they drive into a little bit they figure out, well, you can just make one reaction. Well, maybe sometimes you can, if you go above the really big ones, you can make 16 reactions in a time. But I mean, it's not really high throughput, right? I mean, it takes something like 4 hours to run, let's say, one sample. And if you make a normal qPCR, I mean, you have a throughput, I mean, you have 400 well plates or whatever. So this is how you make diagnostics. And I mean, if you think about a price for a simple qPCR reaction, I mean, students can just calculate them. So I provided them the link for some companies which are just saying the oligos. I mean, we know the prices, right? I mean, more or less every week we are buying oligos. But for the students, they have no idea. So, and then I tell, well, you also have the protocol which was provided to you from the scientists of the Charité. So how much of the oligos do you add to a reaction? So just calculate the costs you have from oligo for one reaction. And then what they are figuring out is that the cost of an oligo, even if you go for some sophisticated labeled oligos with quencher and with fluorophores attached to it, it's nothing. It's less than 0.00001 cent per qPCR reaction. So this is absolutely not the costs. So if you make one of these cartridges, let's say the commercial value, what your production costs, at least in terms of oligos, it's nothing. It's a few cents per test. And it is also what the students should realize if they are doing a qPCR test. Just the test, the material is nothing. You can do it in any laboratory. You just need a qPCR machine. And the costs are, if you calculate it per test, it's nothing or almost nothing. And if we have a good student, I mean, then they are trying to calculate that and figure that out. Anyway, so we had this assignment.
Sorry, Holger, 5 minutes more. I'm sorry.
Okay, no problem. I will speed a little bit up. And then, so we had the assignment. And normally, if you are giving a lecture, so you have different subjects. And normally, if you are teaching, you are starting with subject 1, and maybe you do it on Monday, and then the week again. And then you continue with subject 2 and subject 3. But if you are giving this kind of assignments and the people should handle it back and forth, then it takes you somehow more time. I mean, in week 1, you are giving the assignment, then the week later, they should handle it in. And then you analyze what people are telling you, and you analyze it, and you maybe give them a next assignment. But so basically what I then did is that I were running some of this subject in parallel, so that students were busy with subject 1, and then in the meantime I could analyze their answers, and I can go maybe for a lecture. And then in the meantime they already started with another subject. So that is something students had to get used to. But in the end, it worked. So, I mean, you have to find a way to find the feedback communication, which is disrupted a bit because you don't have the classroom situation. So I just did that spread over different days. And then, I mean, there are also animated PowerPoint presentations. So this is very useful. It also a lot of work in preparing it. But so you prepare the PowerPoint and then you are speaking, so you are taping it. And for example, I made an animated PowerPoint for mass spectroscopy. So I wanted to explain to them how mass spectroscopy is working. And then we used a little example. So I showed this example. And so I asked them, imagine you are interested on what chemical substance is on this knob of this door. And you may know much about this door. You only know that this is a door which belongs to the house of Mr. Skripal. And then you also know that Mr. Skripal had a tense relation to Mr. Putin. And so you are analyzing this kind, so you would like to know what is on this doorknob. And then you are performing mass spectroscopy. And with mass spectroscopy, you find out that you had Novichok on this doorknob. And then at a certain point, your co-workers become less relaxed. I mean, these ladies are still relaxed. So then your question in analytical terms is changing. So you don't want to figure out anymore what is the nature of the chemical substance. You already know that you are dealing with Novichok. And then you would like to figure out, is Novichok also present, for example, here at this place? And you just would like to determine the concentration. So you have different analytical problems. And this is something what you can do with mass spec. So I come with, what means real-time example, but something at least which should be to the students a little bit intriguing. I mean, at least in Europe, it was a lot in the news that Russian secret agents were poisoning a person which were not really in line with say, general Russian politics, and that this was done in Great Britain. So this, I mean, most of the students recognize directly these pictures. And I mean, this was just mass spec which was used for it. So I just went through it. How is mass spectroscopy working? So now I skipped that, you know that. So I went through that, and the students really appreciated this kind of animated lectures because they could just download it, they can watch it, and you present a lot of information which is quite condensed, and they can stop it, they can restart it, they can go through it. And I also gave them some questions with that so that they can control whether they are picking it up, and they handled in these questions, and I was then checking whether they were able to understand. And when they were understanding, well, I gave them the animated PowerPoint. They had the assignment with that, so to check whether they learned. And then I again make one of these online lectures where in live I was discussing with them questions. And this is another example, but this is one of these, a picture from one of these online lectures. So I'm not just using PowerPoint. So I'm using a drawing pad so that I can really have a blackboard in the classroom, that I can draw something for them during the lecture. So this picture is then created during the lecture live, that students can see that as you would normally do that in the normal classroom with a blackboard. And this is also something which the students like. I mean, the problem is, of course, you do this online, and you have, if you are taping it, we have often problems that there is a delay between sound and what you are pointing and what you are drawing, but students still like it. And with that, I'm almost at the end. This is the last slide. So the other thing I had to deal with, so I wanted to use Corona as an example. And on the other hand, you have your normal curriculum. I mean, you normally teach them about qPCR, you teach them about statistical evaluation methods, you teach them about ELISAs and immunological techniques, but you also normally would like to teach them about mass spectroscopy, about absorption spectroscopy, and this kind of stuff. But I mean, in the end, if you would like to stay with the theme coronavirus, you can always make a link for the students. I mean, if you are talking about protein biochemistry, if you would like to generate an antibody against a part of the corona, you need protein biochemistry. You need maybe mass spectroscopy to analyze your protein and this kind of stuff. So you can always then find a way in a wider, broader sense that also this kind of techniques are useful and you need them if you are working with this very specific analytical question, how to crack the coronaviruses. And of course, in addition, you have to give them some background on the coronavirus, which you maybe would not do in bioanalytics, but they have to know how this virus works. And with that, I'm at the end of my presentation. And if there are questions, I'm very happy to take them. And I think we later on still have this discussion. Thank you for your attention. And I hope I was able to entertain you a little bit in the last 45 minutes. Thank you.
Okay, thank you so much for great presentation, and it's really give me some overview that about this. I would say that it's more than Gedanke experiment is problem-based learning. Actually, what I could understand also. Yeah, but I'm sorry, Holger, I forgot to read about your curriculum vitae. So I should read it right now. So I wanted to.
That's not so important.
No, it's important for the attendee to know about the speaker. So Holger Rehmann studied biochemistry at the Ruhr University Bochum in Germany, where he obtained his diploma in 1999. So diploma is in Indonesia equal to the master degree. So because we have also term diploma here, but diploma here more into the vocation education in Indonesia, so non-degree education. So I just have to explain about that because sometimes people misunderstood. Okay, so Holger prepared the PhD thesis at the Max Planck Institute for Molecular Physiology in Dortmund. So Max Planck Institute is one of the very famous institute in Germany. So on biophysics and supervision of Wittinghofer, and defended his thesis in 2003 with distinction at the University of Utrecht, Netherlands. So you have two PhD program, Netherlands and Germany.
Yes.
Yes. Okay. Yeah.
Well, I mean, I was preparing the work in Germany, and then I was defending. So at that time, we didn't really have PhD programs. We just were doing the job in the lab, and then we defended it. So there's a very old-fashioned academic tradition. You prepare your thesis, and then you defend it. So,
yes.
I mean, of course, you could say it was two PhD programs.
Yes.
Yeah. But in the end, it was making the thesis.
Yeah, because it's a little bit different with the, I mean, the point of view a PhD program in Indonesia. That's why in Germany, we call it also like Doktorarbeit, because we have to also kind of a defense. You can defend it not only in your university but also in another university. So from Holger is also joined the group GL Boss at the University Medical Center of Utrecht as a postdoctoral fellow, and then were promoted as assistant professor in 2007. In 2010, Holger became associate member of the Bioanalysis Center, and in 2016, founding director of the Expertise Center for Structural Biology of the University Medical Center Utrecht. So you almost spent many years in Netherlands.
Yes, exactly. Yes.
Yeah. So, and then he stated that you are joining the University of Applied Sciences in Flensburg, started this year 2020,
Yes.
right? Yeah.
Yes.
So So for the publication, more than 50 publications. So if the attendees, the participants are interested to find, just type the name and more than 50 publications already in the website. Yeah, that was the curriculum vitae for our first speakers. So, and then we have actually already some question in YouTube also here I see in YouTube, but I think I will talk about it later in the discussion session, and we have also one in a Q&A, and some people also wanted to say directly to you during discussion later, so not by writing. I think it's okay, right?
Yeah, of course,
and now,
of course.
now we come to the second presenter, Marlies Vitae. So are you there, Marlies?
Yes, hello, I'm there. I'm ready.
Yeah, okay. Yeah, so I will say the curriculum vitae about the Marlies Vitae. So 53 years old, so with 2 children, and from Berlin. So Berlin, and then from 19. So you did your study at the biotechnology from the Canada. You did, this is the master degree, right?
No, first I do. It's like a we have a change in the education system. So the diploma is normally, I think it's something between the bachelor and the master, and then I did the master later.
Okay. And then since 1994, you are already in Flensburg and joined at the Flensburg University of Applied Sciences. At that time, the name is Fachhochschule Flensburg. Yeah, and then in 2010 until 2012, you did your master study at Flensburg also in the FUAS in the biotechnology and bioprocess engineering. Yeah, I think that's it. What I got from the CV. Then maybe you can later add on during the presentation or discussion. Yeah, now I think without prolonging the time is yours now, Marlies. So please.
Okay, thank you, Bukatika, to introduce me to the participants. Selamat siang. Good afternoon to all the members of the University of Denver, to all the professors, the lecturers, the students, and all the other guests. And especially I want to say a warm hello to all of you I've met 5 years ago when I visited Denver University for doing the workshop with you. And furthermore, I don't want to forget to send greetings from Live Tretbar, and who cannot participate, unfortunately, today. So today, I want to give you a shorter presentation than Holger's about the way we deal with COVID-19 and how we deal with the lab activities which were shut down in this moment. So let me share my slides with you. So can you all see my slides now? Yes? Okay. So let me begin with my presentation. So Bukatika and Professor Antje Labis asked me to talk about Corona Best Practice Lab. So for you to know, I'm a lab instructor at the University of Applied Sciences in Flensburg. And when I work with the students, when I instruct them in the labs, I work mainly in the field of molecular biology, fermentation and cell culture technology, but I'm also doing with 2 colleagues of mine the safety briefing, the yearly safety briefing for the students in the lab. So first of all, I want to give you an outline of my presentation. Here you can see the contents, and I like to apologize to Holger Rehmann. Can you? You see my photo I've chosen for this presentation. So sorry, Holger, this is really bad.
No. Sorry for. This is basically the same I used. That's fun.
But when I chose this photo, so I really found this is really beautiful. So the virus. So I
agree. It's very beautiful.
But let's go back to my presentation. And my talk today is about 2 parts. So the first part is about the practical classes at the university before Corona. And in this part, I especially want to show you how we work with the concept LabRite, a concept to prepare the labs in a really good way. The second part, the biggest part, will be about the practical classes at the university with Corona. So this was a little bit complicated to come to the restricted lab activities. So I want to talk about the administrative organization, about our Corona hygiene concept, and I want to talk about the LabRite concept, which was modified under Corona conditions. So finally, the last point will be that I want to inform you about our best practice sharing teaching staff. So how we shared knowledge about the technology which was necessary to do a good job at the university. And finally, I want to give you at the end a summary. So when I want to start with my presentation, I want firstly explain you how we work in the university. So the only online tool we had until Corona came in our life was the e-learning platform StudIP. I think you have something similar at the university. Ours is called StudIP. So this is a course-related internet support of classroom teaching. So this is a forum, the platform where the students can register for a course, and you also can also analyze projects or teamworks, and the students get here all the informations, all the details about the courses. So, for example, for the time, the first date, for the lectures, they can get all the materials, all the teaching documents. So they can upload and download material. We organize the course, so I can see who has registered. They can ask questions in a discussion forum, and we also have an email function and an evaluation feature in this. So and this is how our lab organization was before Corona. So normally the students just register in StudIP, and then they come to the laboratory, and normally the students must attend all lab appointments, so they must be present. They also have to take part in the lecture Molecular Biology from Professor Dr. Antje Labes. And for the lab, the participants only bring in the lab they have to make sure that they got their yearly safety briefing, and they have to bring their lab coat, sturdy shoes, their calculators, smartphones, and their safety glasses. And then, then we could start. So, and for those of you, or not all of you know our laboratories, but they have normal room size. So normally we have 2 or 3 groups with 12 participants. So it's very so in normal laboratory times it's relatively crowded in the labs. So for the preparation for the students, they get their script as a download in our e-learning platform, and where they can get the script for laboratory exercises and all the other information. So so they come to the lab, they doing the lab experiments, and after the lab, the students send the report in electronic form to the lecturers. I think this is quite similar to your organization. What might be different or is a way we like to prepare the students to the lab. And we use here a very useful concept called lab write. So lab write is a concept which was developed by the North Carolina State University. And this exists, I think, since 2004, so already 16 years now. But this lab write concept should guide the students through the entire laboratory experience from before the single student walks into the lab to after he gets back his graded report. So this is the overall description of this concept, and I've given you in this presentation also the web addresses, so you can easily jump into this concept and get more details. So this lab write concept is divided into 4 parts. So we have the pre-lab part, the in-lab part, the post-lab, and the lab check. And I want to explain this a little bit in detail, but I've forgotten to say that this is perhaps not so important for you, but for those of you who also talk German, understand German, there's also a translation of this concept which you can get at the University of Bielefeld. So, but we come to the details of lab write. And so I want to explain you the 4 steps we want to go with the students through the lab experiment. So the first step into the lab is something that the students can do online at home, and it's called the pre-lab. So when they have downloaded the script and the teaching documents from StudIP, from our e-learning platform, they go into the experiment. They go deeper in the experiment. So they have to read the script. They have to get familiar with the procedure of the experiment, and they have to ask and to answer some questions. So the first answer is what is the scientific concept of the experiment? What are the objectives? What do we have to do in the experiment? What are the analytical tools I will use? Do I test something, analyze something, measure something? And they have to be clear about the overall purpose of the experiment. So in an earlier slide, I've mentioned that the best way to make go through the lab is also to participate in the lecture, which corresponds to the lab. And for example, when I talk about in the lecture, I talk about photosynthesis, then perhaps in the lab experiment, I do something with respiration rate. So they have to get the connection between the experiment and the subject in the lecture. So then they have to ask about the overall suppose, and they have to ask what is my hypothesis in the experiment. And after that, and this is already a big, so when you think about the lab report, when they have answered all these things and they were gone through the experiment, this is already the introduction, the first draft for the introduction of their lab report. So and this is completed by a handout which is made by the students for the experiment. And this pre-lab work, which is written by the students, they sent me this in an electronic form on my computer. So, and when they have done the pre-lab well, and so I'm satisfied with their answers for all these questions, then they have the permission to enter the lab. And when I don't get an answer for them, then they are not allowed to participate in the lab. So the pre-lab is a big step. They're well prepared, and then students come into the lab, and this step is called in lab. So it's about setting up the lab, to know that they have in the lab book, in the lab protocol already, what methods will I use, which materials will I use, which substances might be dangerous, where they have to pay special attention. And I also expect that they have already in the lab book written or designed flow charts. They have prepared tables for your data, and then they can begin the experiment in the lab. So they conduct the experiment, and with this preparation, sometimes they're really fast with the experiment, so that they are able to understand the experiment very well, and they can ask also professional questions during the experiment. So after that, they visualize the data during the in-lab session and review the data. And this is also a question when they get the data of the experiment, they have to decide, do the results make sense? And so they can compare them with the data perhaps from the group, from another group. So, and then they can communicate also about the data in the lab. So when they go out of the lab, this is something the students do alone, again, at their home office, at their PC. So they are doing the post-lab. And the post-lab, it's nothing else than the report. So it's a step-to-step manual to write a report and to collect the data. And to collect the data, for example, in an Excel sheet, to summarize the data, and then they write the report. And this is something you already know as researchers, something that's very useful also for their future, for the students' future bachelor thesis. They have to write the report with the title, the content, the abstract, an introduction, the methods and materials, the results, they have to write a discussion, a summary, and a literature. And they do it not in a way that they begin with the title and the content. And I've already said, yeah, they have made a first draft for the introduction already in the pre-lab part, but they do it in an inside-out approach. That means they do not begin at the beginning, they begin in the middle. And they begin with the results and with the discussion. And most of the majority of the students have big problems with the results and with the discussion. And so, because you can write the title very easily, you can write in the introduction the theoretical part very easily. Perhaps you have looked it up in ebooks, but your own data, to process your own data, is for the majority of the students very difficult. So they begin with the methods and the results, and then they complete slowly their report with an introduction, with a summary, and with all the other parts of the report. So, and after the report is written, they go to the last step. So, and the last step is a lab check. So the students check the report for completeness. And there's a special form I will present you in the next slide for that. And they check it for completeness. And then they send me their report via email. And then they get a feedback from me. So I read the report, and I send back a feedback for the students, so they report, but in addition, a feedback form for the lecturers. And it looks like that. When I want to see whether I can use also a laser pointer. Yes, here it is. So this is form like an evaluation. This is an evaluation form. So the lab report, every student gets one with his name and so semester. And so we have here in the form, you see some section points like the title, abstract, the introduction, methods, results, discussion, a conclusion, presentation, and the overall aims of the report. So this is a perfect structure for a student to write a report. And so when I read the report, I grade each section. So you see here in the last column, you see the section scores, and you see what is the difficult part for the students, results and discussion. This is the main score. So here, only in the results and the discussion, you can get 25 points. So so for the right title, you only get 3.75 points. So so I can go through this as a student for the lab check, but also me, I can get through all this point and can grade all the sections. And after I've gone through all the sections, I get a percentage of how much of my how he fulfilled the task of the lab report. And so when normally with our labs, they don't get a grade. So they have passed or they have not passed. But with this formula, I can see when they get over 60%, I can say, okay, they have passed. But when they have not passed, then I send them back their report and with the lab, with this evaluation form, and they can go through it and they can see which part he has written in a good way, and where he has to optimize his report. So, and this is very, very detailed and very, very helpful. So I like to end this part of my presentation, so how we do it before Corona. And I will start with a Corona timeline so that you know what happened in Germany. So it was a little bit the same in the whole world. But normally, so the lecture period starts for 2020 summer semester in the middle of March. So, and this was that was the same time where we have the shutdown in Germany and in the whole, I think also in Indonesia. So at this time of the year, normally we have all prepared. So so I organized the labs with Holger Rehmann and with Leif Tretbar. So we have a fine organization and a time plan. All the labs were prepared, and we looked forward to begin with the lab activities. But there was a shutdown, and our Chancellor Sabine Christiansen she sent us home in our home office with our laptop and with our files, and and we were forced to think about new ways to do our lab activities online and or in a restricted way. So 1.5 months later, so there was the beginning of May, there was a permission to limit limited necessary practical classes by the Ministry of Education, Science and Culture. So it was like so all the lectures were forced to held up in an online mode, and also online classical practical classes. Sometimes there were ways to do it also online, but I think there were the majority of the practical classes were better. There was a better way to do it, to look for a way to do it in the university. So there was a permission, but there was a lot of ways to go and hints to go to finally begin in the middle of May, as a two months later, to realize practical classes with a reduced number of participants with strict hygiene guidelines. So this was our Corona hygiene concept. This was firstly a concept developed by the ministry, and our university adapted this concept for our news. And it was approved also by the local public health authority in Flensburg. And on the right side, you can see all the also the guidelines that we had for moving and for working in the university. You all know those guidelines. So keep 1.5 meter distance to one each other, use disinfectant, soap, use face shields, face mask when you cannot keep the distance, disinfect all the workspaces in between when there are different people working on a laboratory device. Then we had one-way traffic in the whole buildings, and this was labeled by the facility management. We were forced to avoid touching door handles, and also to separate storage of lab coats and personal protection. So, and for breaks, it was there were special rooms for making breaks when you don't work alone in your office, and of course, all the other activities in the university, like eating in a cafeteria or to meet in a cafeteria, the food court was closed, so you had to bring your own food with you. So, but this was not only the only hints. There was a precise administrative way to practice teaching session in times of Corona. So we had to send a file of application to the dean's office. So and this application was in this application we have to bring information about the data of the course, so about the room, the time, the number of participants. We had to make a risk assessment and have to follow a hygiene concept. So this file of application was permitted by the dean, the facility manager, and the president's office. And afterwards, it was sent to the local health authority in Flensburg. So they also read through it and permitted us the restricted lab activities, and afterwards, from the president's office, we got an okay, so we could start with the lab. So this was the way to start lab activities, and when the students came to our labs, they have to confirm in a special form with a signature that they are healthy and that they accept our hygiene concept. And after the coursework, we had to send it again to the dean's office. So this was really complicated. So, but I want to go back to how we prepared the restricted lab activities. And in my earlier files, I have already showed you how we work with our e-learning platform. And so fortunately, our IT team was able to add through new features to our e-learning platform. And you can see it here in red. So there are 3 features called Blabber, VIPs, and meetings. So Blabber is something similar to WhatsApp. So so all of the course participants can meet to a special time, and they can easily communicate via the platform. The second one is the VIPs, and VIPs is a virtual exam system. And this was really new for us because so exams or labs usually happened in the university, but this was a possibility to create special worksheets. For example, worksheets, self-tests for the students, or exams. So with, for example, with single or multiple choice questions. You can create them as block assignments, and afterwards the system calculates you the points, the grade, gives you a grade overview and statistics. So this was relatively new to us. And the third new feature was meetings. So this is called Big Blue Button. And here I have to say at the beginning, it was we used several different meeting softwares. So for example, Zoom or WebEx, but there was always a difficulty especially in the beginning, that the server capacity in Germany was too low, and not all the participants were able to participate in the online meeting. So a big blue button is now a feature where you can where the servers are located in the university. And this gives you the possibility to meet synchrone with the students, and to share also slides with them, and to make an online lecture. So here I would like to show you a table about the corona conditions, and I'd like to compare it how we did our the preparation of our labs. So normally before corona, we met for the first preliminary course in a classroom meeting. So this was not more possible. So after or during corona, during corona, we met via big blue button, the virtual meeting room. So then another thing was the number of students. So normally we have in the lab 12 students, and now we are forced to reduce the number of participants to, so for example, this is for a room of 60 square meters. It was only allowed one person per square meters is wrong, so it's one person per 10 square meters. So for a room size of 60 square meters, it was allowed to work with 6 persons in the lab. So another thing was the group composition. So normally every lecturer has his own course organization. But we and every student choose his group he likes to work with, and but we decided it is better to have now in Corona times fixed lab groups. So we had a good communication between Mr. Tretber and Mr. Rehmann. So we communicated so that the lab groups always stayed the same to reduce the risk of infection. So coming back to our pre-lab, to our lab-right concept for the in-lab, for conducting the lab in the university. So it was for sure we did it in the university, but afterwards we have to think about do we conduct the experiment in the university, because there are also persons at risk which can be for who it is very dangerous to work in the university, and you do not want to risk an infection. So this can be the staff, the lecturers, but that can also be the students. So they can choose. The students can choose if they want to work in the laboratory, if they want to have the risk of an infection or not. Then there were some lecturers doing the lab via video presentations that they recorded in the labs, and we decided to conduct the labs with a reduced volume. Yeah, we also decided to work in shifts. So normally we have university times, so all the labs begin at the same time. And so in Corona times, we tried to work in to shift a little bit the starting of the lab times. So as a pre-lab for the experiments, you can do it for sure. We did it online before. and also after, but extended with new features. And the post-lab and the check lab, this was like we did it before. It was all in online in an electronic form of communication. So let me give an example how we did the lab and to understand why we have to do it in the university. So here in this slide, you can see the production platform GFP for the green fluorescent protein. So this is a platform we like to work on in the labs. So in the first, you see development of a cell line. So this is the molecular biology lab part. I did it last winter semester. So the students did a transformation experiment and to produce the E. coli, which produces the green fluorescent protein. You can see it here on the right side. But when they have produced the cell line, so they go to the production in the production scale to the upstream processing, and they are doing this in the bioreactor in a bigger scale than like an agar plate or in an Erlenmeyer flask. Oops, das schon so. And afterwards, they go to the downstream processing lab, and they're doing a lot of analytics to have information about the purity and the functionality of the protein, as well as quality. They do quality control and the documentation. So I did not do molecular biology, the molecular biology lab in this semester. I did the bioprocess lab in this semester. And in the bioprocess lab, I did a fat batch fermentation where we produce the fluorescent protein. And you can see here in the picture, this is our bioreactor, which is where the students learn to prepare the media. They learn to upbuild the bioreactor. They learn to take samples and to analyze the samples. And they learn to run the fermentation, to store the data, and also to handle the data which are produced during the fermentation. So you can imagine this is nothing I can take in my home office and or bring it to the students. This is something the students must do by themselves. So they must have praxis in this experiment. And they are also allowed to make mistakes in this experiment. And you cannot do this and you cannot have the experience when you are alone in your home office. So the students were forced to prepare the pre-lab extended. So they, at the beginning, we didn't know if we can have reduced lab activities. So we thought that perhaps we can only do it online. We are not allowed to. So we did the preliminary course meeting for the bioprocess lab via Big Blue Button, also our meeting, our virtual meeting room. And then the students downloaded learn units from StudIP. So this was a little bit like Holger already showed us, reported us. This was a script, the manuals, the tutorials for the lab devices. And there was a lot of literature like papers, free ebooks, or supporting videos. And there was also a possibility to download the recorded introducing course meeting for those of the students who cannot attend the first meeting. There were a lot of students also with children who are forced to work in the late hours, or were forced to work during this Corona time. So they had also the possibility to the recorded version. And with this material, we sent a task for the student. So we said to the students group, each student group must present a video about a given topic to the other students. So when we loaded up the papers, each group got a paper to a special topic related to the experiment, and so this is a sort of an inverted classroom concept. So I'm not doing the recording of the video. I'm not explaining what is the paper is about, but the student group must present this in a video with audio function, this paper to the other students. So this is from students and to students, and all the students must see those videos. And afterwards, there was a small exam, something like a self-test for the students, where they get multiple choice questions and questions to see whether they have understand the content of the videos. And with all those preliminary preparations, they were really very, very well prepared for the labs. So when after the videos were ready, the message from the ministry came that we can start with the reduced lab activities. Yeah. So this was really fine, the lab activities. I will tell you a little bit about this later. But I also want to tell you about what happened beside our lab activities. What was very helpful was the lecturer exchange. So there were two possibilities to exchange your knowledge about the technology for online teaching in the university. For example, there was a workshop forum in StudIP in our e-learning platform about teaching in times of Corona with different threads, so that you can communicate and ask questions about special topics in the technology of online teaching. And there was a weekly lecturer meeting via WebEx. So I've listed some interesting topics. So about synchrone teaching concepts, for example, via video conference, via Zoom, Jitsi, or Big Blue Button. So there were always two persons who explained the different tools and softwares. There was a lecturer meeting about asynchronous teaching, so how to do videos with PowerPoint, how to do screencasts, and how to use software Discord. Or, for example, there was another meeting for communication tools like Slack, Etherpad for collaborative writing. And what was very interesting, there was also a meeting with students to hear and to listen what they think about the online teaching, what they like or what they don't like, and what we shall change or make better. So then was also a meeting about digital exams, which was also interesting. To transfer it from the present exams in the university. And there was a very interesting meeting about inverted classroom concepts. Also the concept I've already showed to you, from students making content from students for students. So this was some of the interesting topics of the lecture exchange, and now I came to the end of my. I nearly come to the end of my presentation, and I like to give you a small a summary and a conclusion. How we thought and how we experienced the last 4 months. So for us, the lab activities were and how to do it. It was really time-consuming reorganization and preparation of the labs, but we also stepped forward and we learned a lot. There was a high learning success with interesting new features, which we will surely use in the future. And I'm sure you have made the same experience. So perhaps you can also discover LabRed, or perhaps you use it already as a powerful tool for a good mixture between digital and analog content. And so it really gets you the most of the precious lab time. So we only have a little lab time, and so the students should be prepared in an optimal way. So what was also good in the last time was we had small learning groups. So it was a maximum of 2 persons per group. So they really must make a lot themselves, and they really learn a lot, and there was a lot of communication possible between the students and the lecturers. So is this really best practice what I've showed you? And this is only our way of our working team and in our work in our work team of food and biotechnology group. So I would like to pick up 2 thoughts of the speakers yesterday. So Antje said it's all about human interactions and in the university life. So it's I think we need those lab activities. So the university is also a social room where people come together, students and lecturers, and it's not all about lectures and labs. So we don't need the student or the lecturer all alone in his room before his laptop and preparing online sessions. So, and the second thought I want to pick out is that Professor Didactic says, so he presented a flow chart where the students begin to read the context. He remembers, he understands, and he applies the content. Then he analyzes, he evaluates the content, and then he can also be creative. And for that, I must emphasize this. It's really, really important for the students to work in the labs actively, not only in to see online videos, but because he must handle the situation. He must make the methods himself in the lab, and he must be allowed to make mistakes. So he only can learn what learns. He can only learn what he must be able to do after his study. So so at the moment, this is all I wanted to present you. I'm looking forward for your questions, and I like to say thank you for your attention.
Okay. So thank you very much, Marlies, for a really interesting example, and also great example how to handle the especially the lab experiments during this pandemic time. So now we come to the discussion session, so I would like to give first privilege to the person who are already raised their hand. I ask the co-host, please also help me to handle to promote some of them to be the panelists. Ya, Pak Tarzan Purnomo, Bapak sudah ya, Pak Tarzan, you can now directly say the question to the speakers. Pak Tarzan. Okay. If Pak Tarzan is not yet there, so now the second question from Mirza. Yeah, Mirza. Yeah, you are now online. Yeah, okay, yeah.
Yeah.
So
Halo,
now Mirza.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum, Butika and others. Thank you for the opportunity. Well, my name is Mirza. I'm the lecturer in biology education in Universitas Muhammadiyah Malang. Well, my question is goes to the Marlies for the best practice during the COVID-19. Well, here in Universitas Muhammadiyah Malang, actually, we have a colossal problem actually. Well, we have only one PCR machine for one university in Laboratorium Center, but and also there are 5 faculty that using this machine. So unfortunately, the students, especially for biology department, they can't use it properly, right? And before the COVID-19, we are the lecturer, what is that? Using the videos to show the student how practice with the biomoleculars. And right now, for during the pandemic COVID-19, I just a bit scared, a bit worried about the skills for the student skills, related to the another part of, I mean, it's not only for biotechnology or maybe molecular biology. Of course, in others laboratory, and they need to having a skills, right? And how it's solved by using online practicum in online laboratory. And also for the second question, it's about is it possible for the lecturer? I mean, sorry. Is it possible for the the last student who conduct the research, for their undergraduate thesis to doing her research in laboratory in German, especially. Thank you, Bu Kartika.
Yeah. So Marlies, or I mean, any other speaker can also give comments on, or also try to also discuss the question from Mirza. Yeah, Marlies, are you clear with the question? I think the first question is related with, is there a possibility to have skills even with the online teaching? I think that will be the point of the first question, maybe. And then the second one, yeah, you get it. Okay, Marlies, exchange students. Yeah, okay, yeah, please.
Okay, yeah, thank you for the question, Mirza. So when I presented the pre-lab, my extended pre-lab, I mentioned that I have also downloaded some videos. So I have done not only the bioprocess engineering lab, but also the cell culture lab last week. And for that, I've looked in the wide world web where I can find good videos that showed me those special methods that can support my lab. And for example, for cell culture technology, I looked via the cell culture collection websites, and I've found very useful little videos who showed the technical, how to do it, how to learn the technical skill to use a laboratory device, or how to learn a method. And this was really professional videos, Matt, and this was really a nice addition to the reduced lab activity. But I can understand this. As for some methods, we also have only one laboratory device. For example, for the qPCR device, we only have one. And but with the reduced lab groups and with disinfection in between the work shifts, we can achieve also that many more people can work with the laboratory devices. So we try to use them, and not only to make it via an online video. But I know from colleagues that they recorded videos. They make the experiment in the lab for the students, so that the students can see the whole experiment in a video, like it is done in a normal lab activity time. So I hope this answers your first question.
Yes. So maybe for your information, we are not familiar with the term qPCR, but for your information, qPCR is more familiar. We call it real-time PCR. So
Yes.
RT-PCR, but not the reverse transcriptase PCR, but the real-time PCR. So, but in Germany, it's very familiar with the qPCR because it is quantitative PCR, right?
Yes.
Okay. Yes. Okay.
I think it's a brilliant example for what I meant for this teaching situation, that some people say qPCR, others say RPCR, RT-PCR, so others say live PCR, whatever. So in the end, it more or less means the same. I mean, sometimes you have to make a reverse transcriptase, but normally you know what you mean.
Yes.
But I think, I mean, with the problem you described, that you have only one PCR machine and so many students. I mean, this is a problem you also have in non-corona times. And I mean, this is always if you have expensive lab equipment. But I think what you should always realize, of course, students need some practical skills and they have to learn it in the lab. But you should also be realistic. If you teach them how to operate this particular PCR machine, this is not, in the end, not useful. I mean, each PCR machine is different. You have to program it a little bit different. So in the end, the way how you program it practically, of course, it's good if they have done that. But if you have a young student, I mean, sometimes I have a PCR machine. I mean, it's a different one, not my favorite one, and I got to another one. And then I don't know how to press the enter button or how to change the stupid menu. And normally we have these young students, which are very good with the smartphones or whatever. They are very quick in figuring out how to use this particular PCR machine, how to change. So I think if they understand in general, if you make this Gedanken experiment, that they know what they want, that they know how the program for the PCR, how the cycles should look like, then whether they have programmed it with a particular PCR machine or not is not so important. I mean, it's anyway, each apparatus is a bit different. Each branch, each generation, you have to program a little bit different technically. So, of course, if they have done that once. But in these situations, I always focus on that they understand what they would like to do. And normally that helps them. And later on, they find their way through in the lab if they really do it in practice.
But how about the others practice? I mean, in the molecular work, we need to make some precision for the pipetting technique or something. Right. Then they don't have any skills.
But I mean, you can make a very simple experiment just that they handle pipetting, right? So you don't need expensive equipment for that. I mean, just make whatever, I mean, always try to combine it with whatever experiment you can do. I mean, theoretically, if they should use how to pipe it precisely, I mean, maybe ask them to make a mixture of a wet and a colorless liquid or something like that, so that they and then measure the extinction or anything where you can practice on a very simple way, just the precise handling. So then I mean, of course, they should pipe it. But so I always let them pipetting some cheap stuff, some easy stuff. I mean, just for practice, and I mean, then they learn it. So so it's always a balance, of course.
Yeah. So
but I agree.
Yes. I'm sorry. Please.
No. I just wanted to say whatever they can do practically, of course they should do that.
Yes.
But often you can substitute with. I mean, also sometimes we think, oh, this is a very simple experiment, so they should do something more sophisticated. But for a student, I mean, he has never done something else, so even something we think, oh, this is not really a big deal. For them, it's still fascinating to do that in practice in the lab. I mean, just some simple pipetting can for them be already quite fascinating. Right? I mean,
yeah.
Yes. Okay. Yeah, Mirza, do you have more feedback, or it's enough?
For the first question, I think that's enough.
Yeah. The second question is about the research exchange. Do you mean in that direction?
No, I mean for the last student, I mean for the undergraduate student who will graduate soon, they need to conduct a research, and then it allowed to conduct a research in Germany right now during the pandemic, COVID-19.
So maybe Ancha can help to answer that question.
Yeah.
Because so is it possible, Ancha, now to do the research exchange research program for the undergraduate thesis during this pandemic?
Unfortunately, the major answer is no, as we have this global travel warning, and as long as the global travel warning is, every public funding body will not pay the money for it. So let's say from the hygiene rules and so on, that should be easily possible. But we, of course, rely on German academic exchange. Think so that a real visit, so which we kind of human interaction, just in life. So that is no way. However, some of the universities, including our own, think about kind of a virtual semester abroad, where you kind of join into online teachings at your partner university, which may include also virtual practical courses, plus some extra meetings where you do cultural inversion, kind of thinking about how to practice a new language and so on and so on. I think that's far away from really being abroad, but with respect to getting ideas how differently people teach, so to see how interactive or non-interactive that might be. It's maybe a small but a step into that direction. Still, we keep the fingers crossed that the travel warning is vanishing, so that we can have students being exchanged during that term. So, but I'm only slightly optimistic.
Okay.
Okay.
Yeah. Okay.
Ritika.
Thank you. Yeah. So
I'm sorry, Ritika.
Yes.
My question is not about the exchange, but is in FUAS laboratory, do the students who doing their research for undergraduate thesis, it is still conduct for the research there laboratory?
Okay, I see.
Okay.
That is actually another question. So, but the situation is a bit different compared to Indonesia. More than 90% of our students do not conduct their research for their thesis in university. They go into companies, into external research institutes, and they conduct their studies in that places. However, of course, during Corona pandemic, that is absolutely limited, and many companies have lockdown as well, doing home offices and so on. So I would say in the last semester, approximately 50% of the people being in that thesis semester were able to conduct that, and for the others, we really had to think for alternative approaches in there. as that was really the option, and to give them some theoretical work that they can do literature study and so on. Now we do have the first students doing their master thesis in the labs, and that is not such a big number of students, so they kind of use the labs as all the laboratory engineers, our researchers use it with a shift system, so that we can handle both, that they are under supervision, not working alone, but to comply to the hygiene regulations.
Yeah,
So it means it's equivalent with the thesis, undergraduate thesis, by send the student to the company.
Yes.
Okay.
Yes. Okay. Yeah, I'm sorry, Mirza. Maybe we could also give an opportunity for the other
Thank you, Bu
participants.
Kartika,
Thank you. Yeah.
Prof.
Okay.
Ance and others.
Okay. Okay, Pak Tarzan Purnomo, are you still there? Okay. If not, then let me read the question from the online, from the YouTube participants, because I promised to them that I will also read the question from them, because they were unable to attend the meeting via Zoom because of the connection and so. So the first question is from Semarang for comment. So for Holger, is there like marker molecular for COVID identification? Yeah.
What marker?
Yeah, is there like marker molecular, maybe she means a molecular marker for COVID identification, I think. Yeah, is there any molecular marker for COVID identification? Okay, I think those in that, yeah.
Now, well, I mean, that is of course a question how you define molecular marker, right? I mean, you could argue that viral RNA is a molecular marker, and of course, this is how you detect it in a normal Q or RT-PCR. Of course, what you can do is you detect as a markers of antibodies which are generated by the patient, but there is not really a marker that you say. I mean, any marker, any immune response is not really specific. So you always get a response which is the same as if you have another viral infection. So there is not really a profile or a molecular marker or a protein or whatever, a gene expression pattern which is altering, which at the moment you can correlate specifically to COVID-19. So there is only general markers for general infection. But to my knowledge, there is not really a marker in that sense which would be specific for COVID-19.
Okay. Yeah, and the next question is there any possibility that the antibodies that could recognize corona is the same like the antibody that could recognize the influenza virus? So it might give a negative or positive false detection. So that's what I read here.
Yes, it is actually a problem. So, I mean, it could be that, let's say normally you are using the spike proteins to identify antibodies against the coronaviruses. And of course, there are studies done, but I'm not familiar with all these test kits. But it is, for example, the first one which were on the market when you were testing samples, blood samples drawn from before the pandemic. You had something like about 10% which were positive, meaning that the antibodies were also recognizing other viruses, other coronaviruses likely than the COVID-19 coronaviruses. There are now claims for antibody tests where they say that they have only something like 2% false positives one if you have a true negative one. But of course, this is a problem that if you try to detect antibodies against the coronavirus, you would like to have it against Corona-19. But yes, this is a risk, and you have this risk, and this is what you're observing. So if you calculate selectivity and specificity of your antibody tests, these values are often not Well, the question is, what would you like to achieve? But there is a high risk that you also detect other antibodies against other viruses or whatever kind of antibody which accidentally binds to the protein from the corona-19 you are using. But in particular, other coronaviruses are a problem. So this is what is known and what you see.
Okay. Yeah. Okay, and the next question is goes to Marlies. So, how to evaluate and assess students' works on Corona? I mean, maybe Siemens is how to evaluate and assess students' work in time of this Corona. So during this online lab teaching and so. Yeah, Marlies. How to evaluate the student? Marlies, you are still mute mode, so please unmute. Okay.
Yeah. So, thank you for a question, but I have to repeat it because I'm not sure whether I understand it. So
Yes.
the question is how I can do an assignment or
yes, and to evaluate the students during this time of Corona.
Yeah, during this time. So I have presented the feature VIPS. So this is a virtual exam system. So and there you can create worksheets where you can create a whole exam, and the students at home they have a special time slot where they can answer the questions, and then they send the answers of their exam to the lecturers, and so it's possible. It's possible to make a virtual exam, but perhaps it's also a question to Antje. Normally, we have all the exams in the university in presence at the moment. Yeah,
Okay.
I don't know if this fits your question.
Yeah, so I cannot ask them to give feedback because it was the question in YouTube. So, yeah, because in the streaming mode, they will get your voice a little bit delay compared to the Zoom online Zoom. So the other, yeah, maybe I will move back to the Zoom's question. There is in the Q&A question from Prof. Teja Sari to Marlies actually, but Prof. Teja is actually on. I'm not really sure whether I can understand. So Prof. Teja asked you about to give more elaborate explanation on pure protein and functionality protein. Prof. Teja, if you are there, I would ask you to give a directly question. I already promote you as a panelist, so you could directly say to Marlies what you mean. Prof. Teja, are you there? Or okay? No, so maybe I will just read the question to Marlies more elaborate regarding pure protein and functionality protein, please. Thank you.
Oh, yeah, okay. I think you've...
yeah, Prof. Teja is there. So yeah, okay. Please unmute Prof. Teja. Unmute.
Yeah. Okay. Thank you, Bu Kartika. To Marlies, I just want to know, in your opinions or in your lab, really, what do you mean by the pure protein and the indicator of functionality of the protein that you have been done? Because I really do a lot research on the protein, bean protein. Thank you.
Okay, yeah, thank you, Tia Sari. So I'm sure you have more knowledge in protein protein chemistry than I have. But I can tell you that with a green fluorescent protein, we did most of the analytics in the downstream processing lab. So when we purify the protein in the different steps, we make Bradford tests and we look for the fractions we get in chromatography, how many protein we get. So this is the quantification. And for the qualitative aspect of the protein, we make an SDS page with the student. So to look for the size of the protein and for the functionality. So with green fluorescent protein, it's easy. So it gives the fluorescence when we activate the protein with UV light. So we see if it functions. So we do not make more protein chemistry around the protein. So this is all Bradford and SDS page. And we look in the with a microtite plate reader. We measure the intensity of the fluorescence of our samples. This is all.
Yes. So the functionality of the protein is now determine the physiological functionality of the protein.
Yeah, the functionality of the protein for the important thing for the important functionality for us is the emission of light.
Okay.
The fluorescence.
Okay. So not using the biological analysis. No, only the chemistry.
Yeah, that's
okay. Thank you.
Okay, thank you, Prof. Teja. Yeah. Okay. Now Pak Tarzan Purnomo is already there, so I will promote him. So yeah, Pak Tarzan. Yeah. Please. You were the first one to raise your hand to ask the question. Yeah, the time is yours. Can you? We still cannot hear your voice. Please unmute. Pak Tarzan, ya. So no, okay. Pak Tarzan, bagaimana Pak? Okay, okay. Maybe he has difficulties with the connection. Okay. Now there is also a question in the chat room. I can read it now. The idea of long distance learning using internet connection during this pandemic is very good. However, our students come from remote area where they cannot get access to internet. Is there any other methods to cope with my question? With this, so my question is, do you have any convenient methods to deliver our lesson materials instead of using internet connection? Thank you. So for everybody, for all of you here. Yeah.
Well, that's of course a problem. I mean, if there is really absolutely no internet access, then it's tricky. I mean, we are often also have to deal with that. We have students which don't have good internet access. So in that case, we try to make non-live lectures. So I mean, if we have taped it, and also if we make a live lecture, we tape it so then students later on can download it. But if they have really no internet, well, then the only option would be to go back to traditional surface mail or something. I mean, for example, if you give them an assignment, of course you can print it and you can send it by normal surface mail. Yes, of course this has a turnaround time which is long, but but you could try to, if they have a phone connection, you could make a kind of phone conference, whatever. But I mean, if you have to organize it with big groups and with many students, then it's tricky. So I think, yeah, if they really have absolutely no internet, then it's tricky. But I mean, you could come up with some kind of solutions that you go back to old-fashioned surface mail by printing out stuff and sending then the assignments and this tasks the students should do just on paper, and then they can send it back by surface mail. Of course, then you have to correct that all and look at it. I don't have a better solution. I don't know whether somebody can come up with something how to communicate with these students in such situations.
Yeah. Ance or Marlies, maybe?
Yeah, I think this is how Holger elaborated. I think for one-to-one telephone is really an option, and we do that during the preparation of thesis. So then quite often as students, as I illustrated, are not at universities, but at their remote places, we of course exchange kind of their drafts of the thesis, and then we do it by classical telephone things. But I think there's this absolute limitation to no more than 5 persons at a time. So that will only be an add-on. So, but I think it's absolutely important to think about asynchronous opportunities so that students can really access all the material in the very moment that they have connectivity, and do not rely on kind of online access at a given time. So, and that is not limited to people living remote. So many of our students live together in groups, so having one internet access point in their shared flat, and then of course everybody is downloading everything, so that will not comply with connectivity.
Yes. Yeah. So Marlies maybe wanted to say something as well.
Yes, perhaps. I know from colleagues or also from other universities here in Germany that they pack little boxes for the students so that they are so they can experience, that they can make little experiments at home. So this goes from very elaborated boxes with pH meters, and so there's everything inside to make biochemical experiments at home. But this goes to I know, for example, for our first semester groups, they will do some algae experiments at home, so they can get the algae, and they do some experiments with fertilizer as a medium, for example. So they can cultivate the algae at their windows. So this is perhaps very easy. Or I also know some methods to transform your smartphone to make spectroscopy. So you can be creative, and so there are some it's not a paper, but you can transform your smartphone into a laboratory device, and then you can make little experiments. So I think there's a lot of creative things you can find also in the internet. Yeah.
Okay.
That's all.
Yeah, thank you so much. Okay, and the last question in the Q&A is from the Ika Agus, but Ika Agus is actually apparently here. So Ika Agus, are you there? You could actually say it directly the question. Ika Agus, I will promote you to panelist. So she already there. So Ika Agus, if you unmute, yeah. So you are on. Yeah. If it is possible, could you also turn on the video?
Okay.
Yeah.
Okay, thank you for the opportunity, Bu Kartika. My name is Siska Gusrini. I'm from Institut Teknologi Sumatera. I want to ask for Marlies. In your slide, you mentioned that for the test, especially in lab work, you can use the multiple choice. I mean, if we want to assess the student, how about if we not only use the multiple choice? Because in this pandemic is very complicated to assess the student. Could you explain other method to assess the legwork student, especially in this pandemic era? Thank you.
Yeah. So, Marlies, directly.
Yeah, so it is possible to create a worksheet with multiple choice or single choice questions, but you can even create or design a worksheet with free answering of the students. So you can make a catalog of answers, and then they have to they don't make a cross, but they can write their text. And this goes by an electronic way. So online, this is very easy. This is also possible. So they are, yeah. But I think what is important that you have a time slot that they cannot. So they have a certain time to answer the questions. So so they cannot communicate with the others or. And I know it from my daughter when she had an assignment. So she wrote it with two laptops or with a smartphone. So on one smartphone, on the laptop, she wrote the exam. She answered her questions, and with a smartphone, there was someone sitting in the university looking if she's looking in books or if she communicating with others. So this was the proof that she's not, how do you say, teasing?
Cheating.
Cheating, but you're not cheating. Yeah, this was very interesting. So with two laptops.
Yes.
But I don't know another.
Yeah, I think cheating is a problem ever for in this era.
Yeah.
Yes.
I think it's
Yeah.
also always a question of the regulation of the university. I mean, whether you are allowed to make a formal examination of the student online. I mean, how can you guarantee that it is fair for all students, that all have the same chance, that they have all good internet connections, blah, blah, blah. But also, I mean, if they want to cheat, you can basically not control them from having two other persons in the room somewhere, even if you try to tape them, right? I mean, you can always then find a way that they can cheat if they want, if they are creative. So this is an issue you have, well, we all have to deal with. And if there is no other way, you have to discuss it, I think, with your university and with their regulations. And I mean, you can always make kind of questions that it is not so easy to cheat, that you realize whether the student is understanding, and be realistic. It is unlikely that all the students have a very expert, let's say, biochemistry or whatever sitting next to them. So in that respect, you can of course handle that. But in the end, it's always a formal and legal aspect, I think, which you have to discuss with your university. And then, I mean, make the question, so to say, smart, that you don't give the students too much opportunity or too easy opportunities to cheat. So that's the only thing I can recommend.
Yeah, so much to do for the lecture.
Yeah,
Okay,
so okay, it's enough, Ika? Yeah.
Yes,
Okay, yeah. Okay, thank you so much for the question. And then I would like to ask again Pak Tarzan. Otherwise, we come to the end of the webinar. Pak Tarzan, are you there or still? So, okay. Because he has raised once again his hand, it was, then I promote him again as a panelist. Okay, maybe his connection also. So
maybe
think,
he can put his question in the chat or whatever.
Yes,
so then we read it, or
yes.
I mean, some other way of communication. I mean, we are now creative in communicating with students, so we should also manage that with us ourselves.
Yes, okay, Pak Tarzan, if you can hear me, you can put your question in the chat, or you could put also in the Q&A that we can record it later on. Yeah, after the seminar. Oh, okay. Yeah, I think from the YouTube, for all the speakers, very excellent presentation. This is the feedback. They are very thankful. And I wanted to remind Holger and Marlies, I haven't received your presentation for today, right? I received only the material from Holger.
Oh yeah, I will send you
So please,
the PowerPoint.
if you could send
yeah.
us also update the PowerPoint as well, and then so that we could collect all together. Yeah, I think from the YouTube, because today we have 2 links of YouTube on, and each has their own attendance, so I have to check it.
Oh, you still have a challenge to sort it all out.
Yeah. So there is a very general question. Is there any possibility to collaborate in the research in Germany? This is from our colleague lecturer from, wait a minute, from Diponegoro. Diponegoro is again in Semarang. So, yeah. So, Anja, will you answer? Is there any possibility to have a research collaboration in the future?
Yes, of course. As long as we can start it online. So, but of course we are happy to check what are the possibilities and the topics. As I think that is really important to see that there's a good fit between both sides. But we are happy to support you to find partners as well in Germany. So this is how we understand the collaboration via the German Academic Exchange Service as well. We have kind of crystallization point in the collaboration that we have with University of Denver, but that might be the starting point for making more bonds between Indonesian universities and German universities or European universities in order to foster shared and common research.
Yes, okay. Yeah, I think, now there is one question. I think this is from Pak Tarzan maybe, because this is an anonymous attendee, but he said a connection is on and off. Maybe you could directly answer by the Q&A.
Yes, actually, these are 3 questions, nicely numbered. So he's a physics, so you directly realize that he is giving a good structure to his questions.
Yes.
Okay. The last question is whether I have performed online teaching before the COVID-19 pandemic. Now, basically not. So this is basically the first time that I did this method for online teaching, maybe as it is for most of us. And yeah, is there a good trick to prepare? Well, I'm not sure whether there is a good trick. It's always a way of figuring out what is technically possible and to get experience. And my experience is that it takes more time to prepare a good online lecture than preparing a lecture you're giving in the classroom. I mean, if you're standing in the classroom, well, you know how to do that. Maybe you are more used to it. But if you really would like to make a nice presentation, for example, which you tape, then if it's professional, then it takes time. And I mean, sometimes you see these teaching videos where people are standing in the classroom and then in between you see the PowerPoint slides or you see animations. I mean, you have to be realistic. If it's highly professional, it takes you a week for 1 hour presentation. You have to cut, you need professional taping teams, whatever. I mean, this is if you really go to high professional online teaching. But I think there is a lot of possibilities you can do even with well, in an efficient way with less time that you do it in daily practice. I mean, I found it, for example, very useful to have a drawing pad during my lecture so that I had a whiteboard that I can just draw during the online lecture so that I can develop thoughts and that I can do it like on a normal blackboard in the classroom. But yeah, it depends a lot on also on the size of the cohort you have to teach. I mean, if there are only a few, it's also easier to get some kind of interactive teaching online. If you have a course of 100 or 200 students, I mean, then online to get them really interacting, this is difficult, I think. Yeah, and then there was a more technical question about the COVID-19 and electron microscopy. Well, I mean, of course, you can make electron microscopic pictures of coronaviruses. So there is one thing. So one thing is if you would like to distinguish COVID-19, so this particular coronavirus, which is causing this disease, from similar coronaviruses. So this you cannot distinguish by electron microscopy. I mean, this resolution, they are all the same. And then, I mean, in particular, if you are physics, I think electron microscopy is very interesting and fascinating also from the physical point of view. So there are different imaging techniques. And depending, and this is often generally just all summarized for electron microscopy. So it's totally different whether you go for scanning electron microscopy or whether you go for transemission electron microscopy, or what is now also very popular is single particle electron microscopy, where you are averaging a lot of single particles. So these are very different imaging technologies, all based on electron microscopy. And yes, you can, so to say, observe an coronavirus under the microscope, but at this situation, the virus is dead. So traditionally, you cover it with a thin layer, atom-thick layer, so to say, of gold atoms to get an electron-dense thing which is scattered by the electron beam. So it's just a physical problem. If you have your electron beam, you can imagine if you shoot on soft matter, you just destroy the matter. So normally you make, so to say, a negative print in a lot of imaging techniques by covering it with a thin layer of gold atoms, this kind of stuff. And from that, of course, you can get structural information on the virus, but it is not that it is something live like a movie. And I mean, you can also, I mean, well, as a physics, you for example measure electron intensity, and this you convert to an image. And at a certain point, if you like, you can add all kind of false colors, whatever you like. But this is then just the color editing. So the real data you get, they are very informative, but they are looking very different from what you are seeing in this animated, very colorful, whatever cartoon-like stuff. But still, I mean, in particular, in the last years, there were a lot of revolutions and breakthroughs in electron microscopies, in particular with improvement in the detectors. So now if you go for averaging, so that means you take images even from single proteins, if they are big enough, and then you collect, let's say, 100,000 images of 100,000 the same protein, and then you can project them. So it's so you can reconstruct. You can really get high resolution up to 2-3 arm strengths by reconstructing the protein structure from electron microscopy. But these are different techniques. So you're not seeing a single protein in the electron microscope as a picture, but you are averaging a few 100,000 particles, which you have just as an a snapshot, just a projection. So you have the projection of all kind of different angles, and then you can calculate that back and you can reconstruct the three-dimensional structure. So this is all possible with electron microscopy, and this is very fascinating from the technical point of view, and very informative, but just then different from these simple, colorful, cartoon-like pictures you are seeing. And often what people, if they are making these pictures, they always make it looking like a surface, like you have it on the macroscopic scale. But I mean, you are on a microscopic atomic scale. So you don't have a flat surface which has different colors or stuff like that as you have it on your table or on your cloth or something. I mean, you are looking at molecular structures in the end. So this is where you have these limitations of all this animation stuff. So
I think all has been answered. I think it was from
I hope so.
Yes.
Otherwise, contact me later by email, and then we can discuss.
We will give an email of all the speakers in the e-module that we will send to all the participant letters. I think now we are really almost really on time from the time. So this is 5 minutes before 4. This is really our schedule. So there are many participants who give feedback that they are really thankful for the great speaker, great presentation, and great sharing related with the coping with the pandemic. Some of them put it online, some of them message it to me privately. So thank you so much for today. I would say I really thank you for Anja, for Marlies, for Holger, for attending this webinar and sharing so many experience. And I cannot really summarize so many experience for all of us, so many experience also for me. So we really hope and that this exchange of the method, this exchange of experience really will improve our teaching, especially during this situation. So maybe I would only ask one more last thing. If you wanted to give a close statement from Ance as the first speakers, and then from Holger and from Marlies. So one close statement. Yeah, please.
One close statement. I try to have not too many sentences in that setting. No, thank you very much, everybody, for joining in and raising questions and so on. I think for both of us, when we developed the idea of that shared seminar, was kind of we call it a starting balloon, so a test bed. And I think we learned that this binational or even multinational exchange of ideas is a good setting. And this is actually my learning here. So that coming into contact based on a long-standing collaboration is easy. So, and this is a good learning that we should continue and even speaking frankly together on our own experiences and not saying, yeah, that is better here or better there. So I want to encourage everybody to continue with this exchange, as this will develop our personalities and that will be of benefit for all our students. So thank you very much for sharing those 2 days together.
Thank you also. Yeah, Holger.
Yeah, thank you all for attending, and it was really nice to present. And I think what we also learned in this discussion is that we are all over the world are facing with the same problems in teaching, how to reach the students, how to do that. And I mean, there is maybe no optimal way to do that, or there are many ways, and we all have to try. And I think it's very important to be creative and to try to find solutions. And maybe we will never be able to really fully substitute traditional teaching, and in particular, if it's about lab work. I mean, students have to work in the lab. I mean, otherwise it's not possible. But on the other thing, and I think there are also some things which we now learned, and there are some things which I thought that I would also continue if we are back in normal times. So, for example, this animated PowerPoint presentations where I put the voice line in, students appreciated that a lot and they liked it. And I thought that I will do that also in the future, that I just give them some of these PowerPoint presentations which I have spoken on forehand. And I mean, then what I'm saying there is more maybe professional and designed than what I'm doing during the lecture. And then they have the time to go forward and backward, and they can prepare. And then later on in live, in the real lecture, I can discuss more stuff. So I will definitely use these elements also in future. So in this way, I think we all find our ways and we will learn from it, and we find ways, and in the end it will work. And thank you again.
Thank you also. You're welcome. Yeah, Marlies, the last one. Please unmute Marlies. Okay.
Now, thank you for your attendance, and to Bukartika for developing and for running this webinar. So this was the first time I was part as a speaker in a webinar, so this was also new to me. But my previous speakers, so Antje and Holger, they said I think they all said the things I also think, and so that the online teaching cannot replace the classroom teaching, but as we all have seen, that there are a lot of new features and methods to optimize the teaching in general. So I profit from this a lot, and so this is all I have to say at the end.
Yeah, okay. Thank you so much for all the speakers. We do hope still that we will have a better situation in the next semester, next year maybe, and you are all very welcome to come to Indonesia and give directly improvement of teaching offline. Yeah, I think we come to the end of the webinar from me. Thank you so much for all the attendees for this meeting. I'm now I will give back the time to the Bu Endah, to the master ceremony of today. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Assalamualaikum.
Yeah, thank you, Bu Kartika.
Thank you.
Ladies and gentlemen. Now we have come to the end of this program. The committee would like to express our sincere gratitude and appreciation to all the speakers, the moderator, as well as all the attendees joining fully from yesterday. I believe this could be a fruitful discussion and enhance our knowledge all. Finally, the webinar committee would like to deliver apology once again for any inconvenience, and we hope to meet you again in our next agenda. The certificate will be sent to your email once you give the feedback on the link given. I believe you all has already filled the form, right? Okay, thank you. Good afternoon and have a nice day. Good morning to all the Germany people.
Yeah, bye-bye. See you next.
Assalamualaikum warahmatullahi
Bye.
wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Yeah.
Rahman.
Bye.
Yeah, bye-bye.
Goodbye to everybody.
Yes, bye.